In this complete crash course for beginners, you will learn basics of Unity and C# by making a very simple 2D game where you need to fight off the enemies to protect a little girl. We take no rush when we learn new things, and I try to explain logic behind every step we take. You will learn about Unity, C#, and we're going to discuss object-oriented programming as well. This course is mostly for those who has a very little experience, but if you do want to make something more complex and interesting, like let's say an RPG game, there will be opportunity for that as well. This video has timestamps, so it should be easy to navigate, and if you do have any questions, please leave them in the comments below. I read them all, sometimes twice a day. Now, I hope you are excited to get started. Maybe make some tea and let's begin. In this one, we're going to start simple. We just need to get Unity on our computer. If you already know how to download Unity, or if you already have it, I only want to suggest to use a Unity version that I have, or at least similar to mine, all right? I'm gonna explain why in a second. As of now, let me just show how to download Unity if you need it. So I'm on a Google website and you can search Unity on Google over here, or there it is, Unity, or you can go to unity.com in the address bar, just like that. And then you need to make an account. I already have one. I'm not gonna show you how to make an account. That part should be pretty easy. And then you need to find download button. They do change home screen from time to time. It is always looking different every time I'm making a new course, but overall download button is extremely easy to find. So you go download, and then you download, and you're gonna have a Unity Hub available. You might need to choose plan and pricing, but don't worry about it. You just choose Unity Personal and that's it. Unity is free to use, and you can make any type of games on a free Unity version. You don't need Pro for that, absolutely. I never had Pro license in my life. Now, once you download and install Unity Hub, you're gonna have something like this on your screen. Over here, before you download Unity Editor itself, I suggest to go to settings over here and set up location for your Unity editor. This will define where editor will be installed. If you like to keep your computer clean, this is the way to do it. And then you should also choose projects and find a way where projects are going to be stored. Otherwise, it might save it somewhere in documents or anything like that, which we don't really want. Once you did these settings, you can go ahead and find Install Editor button under Installs tab over here. So you click the button, and now we need to choose Unity version. At all times, it's easier to choose recommended version. It usually has LTS sign over here. LTS means long-term support, and usually it means that it was tested and it's working fine. And that's what you usually stick to. But that is if you're making your own project and you already know your way around Unity. If you're just learning Unity, which I'm assuming you do since you're watching this tutorial, I highly recommend using the same version of Unity as I have in this course. In this case, it is Unity 6.0. If you don't see Unity 6.0 in the list, you can always go to Archive over here, and there you can find all Unity versions that was released before. And no worries, I'm going to explain the reason in a minute, okay? As of now, just know that I'm going to be using 6.0, and in my case, I only have 0.38 available, but you can get like 6.0.52 or 6.0.64, whatever is available to you at the moment. Then you're going to be fine. But I don't recommend using like Unity 6.1 or 6.2, or maybe Unity 7 comes out at some point. And the reason why is Unity gets new updates all the time, and sometimes things move around. It may look slightly different or even get new name for a button. Some button might be in a different place, or some piece of code might work a bit differently. I'm gonna show you a couple of examples in a minute as well. So if you are new to Unity, those changes can be quite confusing and frustrating. You might spend more time trying to figure out why your screen looks different from mine, and why do I have this button and you do not have this button, right? So you might spend more time on that rather than actually learning and building your game. That's why I highly recommend to get the same version as I'm gonna get right now, just to avoid all that confusion in the future. And once you get more experience, once you feel more comfortable with Unity, switching versions will not be a big deal for you. It just becomes a second nature to adapt really. As of now though, just to make it easier to learn and follow, Let's get Unity 6.0. Let's click install. Over here, you need to be sure you install in Microsoft Visual Studio Community. If you are on Apple computer, you're going to have Visual Studio Code. And these over here are not important at the moment. If you need them later, you can always add them to Unity later. So just ignore it for now. So click this and let's go continue. Yeah, I have read conditions, it's fine. And it's gonna download it and install it. While I'm waiting, let me give you some examples on why it is better to get same version of Unity as I have. They usually do changes like new name for a button. Button is still there, but it is named differently. And if you're a beginner and you're just learning, it might be a bit confusing when you're watching the video. For example, I can say, let's create C# script, and this is how it was named in Unity 2022. But in Unity 6, they changed name of a button from create C# script to create new mono behavior, which is essentially the same, but it is named a bit differently. And if you're a beginner, you can get a bit confused by that. Another example is that they changed how you adjust velocity of the object. In Unity 2022, we had rb.velocity. In Unity 6, we have rb.linear velocity. And as you can see by these two examples, and there are a couple of more, the changes are not that big. But if you see this for the first time, I reckon it would be confusing, because things simply look different. So yeah, just get the same version, learn by examples, then it will be fine. If you do feel like getting later version and you feel a bit adventurous, you could do that. Unity even gives you a hint sometimes to let you know what was changed, so it is fine as well. Just make sure you understand what is going on and be ready to troubleshoot a little bit if something does not match exactly with what I have on the video. Alright, good, we got that out of the way. It will take some time to install it, and I don't want to just sit and wait and look how this bar goes from left to right. So once we have some changes on the screen, I'll get back to you. Alright, here we have Visual Studio Installer. Let's open it. It's gonna download and do some stuff. Okay, inside of this window, you just need to be sure you do install this game development with Unity, right? This is an important one. Other things are not as important right now. You're gonna go ahead and click install while downloading. Let's do it. And again, if you need any of these later on, you can add them later. Install while downloading, install. While it's doing that, let me minimize this and let's go to projects and create the project for us. I'm gonna click new project over here and make sure location is correct over here like that. And I suggest to uncheck Unity Cloud over here because we don't really need it in this project. So let's just uncheck it. Then you need to give a project a name. I'm remaking the project, so I'm gonna call it Udemy Course RPG New, right? This is gonna be a good name for me, I guess. And then we can go ahead and choose Universal 2D Core. It has some presets for 2D development, so this is the best option. But if you choose something else, don't worry about it. Again, it's all can be adjusted at any time. And over here, you can choose editor version. I will choose the one I just got. Let's click Create Project. It will take some time. And while it's doing that, let's go back to Visual Studio and see what we've got there. Have this and this window. Signing into Visual Studio with my account. It's gonna do that automatically. And we have it ready. We don't need to create anything. We can just close it because later on, when we create script inside of Unity, it's gonna open Visual Studio automatically. So it's fine. Okay, let it finish the thing. And once it's done, I'm gonna get back to you like in a second and tell you what we're doing next. All right, we've got a new project. This is good. Let's do one minor change to it and we're good to go to the next video. Over here, we have some settings that are about visuals of the game. So I suggest we take these two files and drag them into settings folder like that. So they're not cluttering up things over here. And another thing is input system action. This one is about new input system. We're gonna talk about it in the main part of the course. As of now, we can just ignore it. And we're gonna make a folder. Let's call it input system and just drag it over here. All right, this is good. Now let's go to the next video. Hey guys, just want to give you a bit of a heads up. Sometimes you may hear me saying in the main part of the course. Don't let it confuse you, and especially don't let it discourage you. It's only because I've included this crash course you're watching now into my big RPG course as a bonus content for those who does not have much experience but they really want to make an RPG game. It doesn't mean that this crash course is not completed. It is, and you will have a simple 2D game as I promised, and you will learn a lot as I promised. I'm telling you this because I want you to know that there is no things hidden behind the paywall. You will not have your project done halfway, you will complete it, and I did spend a good amount of time to make sure that you will have a good start into game development if you decide to watch this video and learn from me. I don't want you to feel like you have to get an RPG course, otherwise you will not learn anything. It's not true. You will learn a lot in this video. And of course, RPG course does offer you more content and more knowledge because it's 60 hours instead of 6, but it's an option. It's not an obligation. All right, let's continue. In this one, I want to discuss basic windows and tools of Unity, so you feel a bit familiar with the environment. We don't have a goal of remembering everything I say in this video. You don't have to memorize all the information. You just need to know why we need this and why we need that. We're going to use all of the tools and windows a lot in this project, and with the time and experience, you definitely will learn what each window and tool does. But as of now, let's just get familiar with them, okay? To make explanation easier, I'm going to create a square over here. And I'm going to make another, maybe a circle. Let me take the circle and move it down like that. Okay, so we're going to start with a game window over here. In the game window, you can see preview of the final version of the game. Basically, it shows you what player will see when they play the game. And here you can observe and see your game as it will be when you build it. In the scene window over here, however, you see things as a developer. Basically, it's like behind the curtain view. You see everything as a developer and you can adjust and move things inside of this window. How we do that, we're gonna discuss in a minute. As of now, let's just acknowledge, I guess, that this is how player sees the thing, and this is how you see things as a developer, all right? In the hierarchy over here, you see objects that are available to you in the scene. You can see we have main camera that allows us to render objects and show them to the player. We have light, and we have square and circle I created before. From here you can select the object, you can rename it, you can change it in some ways, and so on. And over here you have inspector window. Inspector window is basically a close-up look on the object. It shows you what properties this object has. It has different components that allow objects to behave in a certain way, and we're going to discuss components in the next video. As of now, you just need to know that this is basically a close-up look on the object that allows you to adjust position maybe, or adjust scale of the object, or adjust how it looks. Later on, we're going to create custom components that we will use to set up movement of the object, for example, and we're also going to use built-in components of Unity that will allow us to make object heavy or big or small, or different things. You'll see. Let me just make it white again and set scale to 1. And over here we have project window. Project window has all of the resources you've added to the project so far, and it allows you to manage resources of the project and add them to the scene or to the hierarchy. As example, you might have a player script over here. Let me name it player. So now you have a player script in the project and you can drag it on the object over here, and now this object has player script. You can add some functionality and you can control it, right? Okay, that's basically it. Let me remove it and let me delete it. We're going to talk about components later on. As of now, it's not that important. We also have things like console and animation and input set and animator. But there is no point of talking about them right now because we're going to use them in a while. And once we have need for them, I'm going to explain what they do. If you don't have these windows like console and animator, you should know that you can go to window over here and find them and enable them. As example, let me close the console. Now I don't have it. You go to window, general, and you find it here. Same for any window you have. And same as with any editor software, you can drag windows around and adjust them as you like. So far, I've learned that this is the best setup for 2D development, and this is what we're going to be using in this project. Lastly, I want to discuss these tools over here. These are tools that we use a lot during the development, and usually we don't bother to go here with the mouse and click them to choose a tool and then use it. We use hotkeys for them. Let me explain what the tool does and how you can enable it with a hotkey. So let me do horizontal so it's easier. And basically we have tools arranged from left to right, and you can select them by clicking hotkeys from left to right on your keyboard. It's going to be Q, W, E, R, T. Right? So this is how you switch between them. It makes it easier to remember them that way. And Q tool, which is a hand tool or view tool, allows you to move around the scene and maybe adjust something. Usually you have a scene that cannot fit into one window, like I have here. You might have part of the level here, part of the level here, and when you want to move around, you can simply use a view tool. But there is basically a tip for that will allow you to do it even faster. You don't have to select a view tool with a Q every time. You can just use a middle button of your mouse, which is a wheel. You can simply hold it and move around like that. Makes it easier, and that's what I will do in this course. Now, next tool is move tool, and you can select it with a W. When you're selecting an object and you need to move it around, it's much easier to press W on the keyboard and move it around rather than adjusting position in the transform like that, right? You can simply just take it and move it. You can zoom a bit with your wheel on the mouse and adjust position as you like. Next tool is rotation tool. You can select it with an E, and this allows you to rotate the object as you like. It's not very useful in 2D development, to be honest, but when you're working with a 3D project, this one is used very often. So this is how you can rotate the object. There is also a scale tool, which allows you to scale the object, but with a scale, you usually have a precise number you want to use on the object. You want to make it 2 times bigger, or maybe half size smaller, or something like that. In that case, it will be easier to adjust value over here with numbers, rather than trying to catch value moving the thing over here. Okay, so we barely use this one. Let me just undo changes. And another one is a rec tool. This one is used when you're prototyping something in 2D project. You can stretch the object like this and adjust it to fit your needs. For example, you want to make a platform like that, and this is what you can do. You can make a platform and then move the circle above and test some physics or something like that. This one is also used when you're working with UI elements, because usually you need to adjust UI button and place it in a certain way, and this is the best way to do it. There is also a transform tool, which combines all of the tools we discussed before. You can select it with Y, but I never use it. I usually need to adjust something specific and not all together. But it is available and it's nice. There are some other buttons here you can see, like these buttons and these buttons and these buttons over here, but they're very specific and we don't use them as often. So when we need them, I'm going to talk about them. But overall, you can just ignore them for now. Don't be too focused on it. Don't overwhelm yourself with information and just try to, catch up on things we're doing and focus on the things I'm explaining. All right, now before we finish this video, let's quickly do something here. These windows, this small window with buttons, can be moved to the corner like that, or like that, or you can place them somewhere here. so it does not clutter your window here and you can see more. Because sometimes, just sometimes, you have an object over here and you want to click it, but there is this window and then you need to move it and then select the object. It can be annoying. So instead, we're going to place it over here and we can even click right button and do collapse. Now it's going to be small. If you need something out of here, you can do this, find what you need and click it. But as of now, we're just going to collapse it. And I also want to take this window and move it here. And I'm going to keep it open so you can see what tool I have selected. As of this one, I think I'm going to collapse it as well, like that. In this one, we're going to discuss components of Unity, what they do, why we need them, and how do they work. Just in case, I'm going to say that I've created square and a circle over here, but if you don't have them, you can go ahead and click right button to the object, sprite, circle, and you just place them somewhere here, for example. Then you need another one, make to the object, sprite, square. You take the square, move it down with move tool, then press T on the keyboard and stretch it so it looks like the ground object. I mean, like a platform, basically. So what is a component? Component in Unity is sort of like a behavior or set of properties that allows you to give an object functionality. For example, sprite renderer over here makes object visible. If you switch it off, you can see object now is invisible. If you just remove it totally, again, you're going to see we cannot see the object. You cannot remove transform component because every object should have it, because that's how we know where object is placed in the world, what its position, rotation, and scale. This one is must-have, but other components are optional. Let's discuss a couple of properties that sprite renderer has to understand how components can affect the object. As example, you can change color of the object, and we're gonna set dark blue over here for the platform. And maybe let's go over here and change the name from square to platform. All right, so now this object is dark blue, and that is because of a sprite renderer and because of the changes we did to the color field over here. There are a couple of more properties, and when we need them, we're going to discuss them. I don't want to storm you with lots of information right now, but just so you know, again, as example, sprite defines how object looks. Here on the platform, we have sprite of a square. On this object, we have sprite of a circle. Later on, we're going to have enemies, and we're going to drag image of a skeleton to this field of the sprite to make object look like a skeleton. This is what component of sprite renderer does. Another example of properties of this component is order in layer. This can define which object is rendered in front of which object. As example, if we take circle and move it down like so, we can see in my case it is behind the platform. In your case, it may be in front of the platform. And we just need to be sure we can set correct behavior for these two objects. For that, you can go ahead and change order in layer. If I make value bigger than the value I have over here on the platform, then circle will be drawn in front of the platform like that. If I make it lower than I have on the platform, like -1, then it's certainly going to be behind the platform, just like I have now. All right, so now we know how to adjust visuals of the object, right? This is a simple example, and there is much more to that, but let's focus on simple for now. Now, what happens if I add another component? For example, I can type here rigid body 2D. Because we're going to be making 2D game, usually we select components that says 2D on it. So let's select rigid body. Now you can see we have rigid body on it, and simply to say rigid body makes object behave like it's a physical object in a real world. If you go to play mode right now, you're going to see how object is falling because it has rigid body on it, and it's going to fall endlessly. If you change some properties, it's going to adjust behavior of the rigid body on this game object. For example, you can change gravity scale to make it heavy. Let's try 5. Now I'm gonna move this object higher, and if I go to play mode, you're gonna see this object falls faster. Yeah, so that's how you can adjust behavior of the object with a component. Now, you probably noticed that this circle, or let's maybe name it as player, we can press F2 and name it player, falls through the platform, which not supposed to happen. It is not ideal scenario for us. That is happening because we have visuals of this object, and we have visuals of this object, and we even have physical qualities on this object. Now it is fallen as it would fall in the real world. But Unity does not know what is the actual shape of the object, because we can see the visuals, but for Unity it's just visuals. Unity doesn't know how object is shaped. And for that, we usually use another component that is named collider. We can go to player and add component of a circle collider 2D. And let's go to platform and add component of a box collider 2D, like that. Very nice. Now we have box collider and circle collider on this object. If we go to a play mode right now, you're gonna see how player is falling and stops on the platform. Because now Unity knows what is the shape of the object. It knows that this object is heavy, it should fall, but this object is not heavy, it just has a shape, so it stops the player from falling. And this is how you adjust and manipulate game objects to make them do what you want. Something else about colliders, which is quite important, you can adjust the size of a collider, and this will help us to understand that visuals do not define shape of the object, only look of it. You can click this icon over here to adjust collider of the ball, and we can try to increase it like that. Now, if you go to play mode, you're gonna see how player is fallen, player object is fallen, but it kinda hangs in the air because shape of the object defined with a collider, and this is how it looks right now, right? That's the idea of it. There is much more to that regarding rigid body and collider, but we're gonna discuss it later on. As of now, let's change radius to 1, or was it 0.5? Yeah, 0.5. I guess we also need to change offset back to 0, and now it's going to be in the center. Another quick example on how you could manipulate game objects, which is not really important right now, but it's kind of fun to observe. If you click right button and go to Create 2D Physics Material 2D, you can make a bouncy material that will make this ball bounce. Let's name it as bouncy material. And let's give it bounciness of 0.7. Now we can go to player and drag this material on rigid body. And then we go to play mode. And now we can see ball is bouncing like that. Right? And you can adjust properties of this bouncy material to make it behave differently. Pew, 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 and so on. Yeah, so this is one of the ways to manipulate the object by changing its properties. We did change material, and now it's behaving completely different. I would like to show you more on components. Sometimes, let me delete this one. This was just an example. Let me delete it. All right, so sometimes, actually most of the time, built-in components are not enough. We also need to make some custom behavior. In that case, we can use custom components that we create by ourselves. I'm gonna collapse these for now, and I'm gonna make C# script, which is named MonoBehavior script now. Let's open this and let's name it as player. Now let's drag the script on the player object and let's open it. I'm going to talk about scripting and variables and functionality in the next couple of videos. I'm going to explain everything, but as of now, just copy after me so I can show you how you can affect behavior of the object with a custom component that you create by yourself. Let me switch this to 135. This is how I used to have it. Maybe 140. Yeah, this should be good. Again, I'm going to explain what we do in here later on. I'm going to go over this once again, but as of now, just repeat after me so we can make the functionality, okay? You remove this, And above, you make public rigid body to d rb. Then in the update, you do this: rb velocity, linear velocity equals to new vector 2. And here we're going to type input get axis. And here we need to type horizontal. Make sure you spell it right. It should be horizontal. And then after comma, for y, we're going to type rb.linearVelocity.y. This is it. Let's save this. Let's go back to Unity. Hello guys, it's me. After publishing the course, I'm taking a look over the Q&A section just to see if everything is right. And one of the issues that got my attention is this one. So over here, students reported that they're trying to use the input and it's not working. I want to give you a heads up. That is because it is most likely that in your Unity version, you do not have old input system enabled, and while we're working on a crash course, we're testing things with the old input system. This is what you need to do to fix it. You go to File, Project Settings, find Player tab over here, and then scroll down and choose both over here. That is if input does not work for you, all right? Other than that, it's all good. Thank you for paying attention. Let's continue. Now you can see we have RB field in the component. Same as we did assign material before on the rigid body, now we can assign rigid body on the player script. And to do that, we simply need to drag it over here. Now, if you go to play mode, you will discover that you are able to move ball from left to right with your keyboard. You can use A and D on the keyboard or arrow keys. And you can see it moves to the left or to the right. Yes, it's very slow and it can do only that, but here it is. With a simple example, with a simple custom component, we changed behavior of the object. And now, even out of this, you could make a fun game, really. Quick example. You can add rigid body to a platform, and this time you can go to Constraints and freeze position on the X and Y. Now, no matter what, this object going to be attached to the place as it was before, but now it has physical properties. And now you're going to see that when we're playing with a ball on the platform, it does this rotation, which is very difficult to manage. But maybe if we could add angular damping, which is air resistance. This value adjusts how quickly the object's rotation slows down. The bigger value you have, the faster object will slow down when it's rotating. You can see now it's rotating slower. Let me try more. Let's try... Actually, let's leave the damping as it is, and let's increase mass of the platform to 5. So it's heavier than player we have. And now it's like that. And now your goal would be to balance out the platform as long as you can without falling, which also could be fun, especially if you play it on the phone, right? Imagine you need to turn your phone to do this correctly. Yeah, to make it harder to play, you could decrease the mass to something like 3, and now it's much easier to turn around, and you need to try more to balance on the platform. So yeah, this is how you do it. This is how you make video games in Unity. Essentially, this is what we need to do. We use components to manipulate objects and make them behave in a certain way. Just when you try to make more complex game, it's getting more complex with more components and more setup on a custom components and so on. And we will do that in the crash course, and we're going to do that in the main part of the course. As of now, this is good. Thank you so much for paying attention. Maybe try to answer this question. Doesn't matter if you get it right or wrong, just try to answer what is a component in Unity. And when you answer the question, speak out loud. Don't speak in your mind, try to actually say it. Okay? In this one, we start discussing programming. And programming itself is a very complicated topic. I'm sure you understand that I cannot explain everything in a 10 to 12 minutes video, but it's okay. I'll do my best to cover the basics that we need to get started. Overall, we're gonna do coding about 80% of the time in this course, so there is no doubt you will have a lot of practice. But before we jump in, I want to explain my approach to teaching programming together with Unity, so we are on the same page with you. I am not a big fan of theory before practice. Mostly because, personally me, I never understand what person trying to explain to me until I see it in the action. If someone explains how something works, I will understand 0% of it until I actually see how it works. And I know a lot of people feel the same way. That's why I try to avoid too much of a theory, and instead I prefer to practice and show what we learning and explain it as we go. This way, you can focus on what's important right now without getting overwhelmed with unnecessary information. You also should know that when you're starting out, there is a lots of things to learn and remember. And definitely you will not understand or remember most of the things we talk about right now. And it's totally fine, it's like 100% okay. Because when you see something for the first time, it might not make much sense. But when you see it for the second time, it's gonna feel familiar because you've seen it before. Then third time you'll see it, you'll recognize it, and you already will know how it works. And on the next time you will actually know how to use the knowledge by yourself, and you will be even able to predict things we're going to write. Yeah, so basically what I'm trying to say here is that I'm gonna show you things, and as a beginner, your goal is to keep up as best as you can, and with the practice, you'll get better. And if I don't explain some parts right away, it's only because I don't want to overload you with information, and when the time comes, I'll explain the missing part as well, okay? So programming mostly starts with variables, and that's what we're going to discuss in this video. Let's go to player script, and before we start discussing variables, I just want to simply explain what is it. A variable is like a labeled box where you can store different kind of data. For example, numbers, text, or some other values. And instead of writing the same value over and over again, we put them into a variable and reuse them whenever we need them. And even if you never did programming, I'm pretty sure you created variable before. If you ever use the mobile phone, when you get in a new friend or you need to save a number, you creating a new contact, you give it a name, and then you write down the number. And next time, instead of writing number again and again, you simply find the contact in your phone and you press it and you call it. And that is essentially saving variable of a type number with a name that you chose for this contact. And then you reusing variable to use this number again and again. And it's very same in programming. We actually did create one variable before. We declared this variable over here in the last video, and this variable was type of rigid body with a name RB. And later on, we used this variable to speed up rigid body and make it move. But as of now, this feels a bit advanced, so let's delete everything from here and let's create a new variable. When you're creating a variable, first of all, you should give it an access type. There are different access types, and we're going to talk about them later on. As of now, for sake of easier explanation, I'm going to use public. Let's type public over here. Then we need to define what type of the variable we want to have. And I want to start with simple. I want to start with the text. So the type of the variable will be text, and in C# we're using string for that, string. And after that, we need to give it a name, so later on when we want to use it, we can just find it by its name. We're gonna call it, let's say, player name. Right, so there we have it. I'm gonna leave a comment, and when you want to leave a comment, you put 2 slashes, and whatever is after slash will not be used by the program, it will be just ignored, so it's only for developers to see and read. And just so it's easy to remember, I'm gonna write something like this box, which is variable called player name holds the text, right? Another addition to variables, when you declare them, you can actually not just declare them, but immediately assign the value to them. So you could write public string player name and then equals and give it a name. For example, Bob is playing the game, right? And that's the variable by default. Later on, if you want to adjust and change the variable, you can do that as well. You could do something like, let's type start over here. We're going to talk about start method later on, but let's say at the start, we want to add something to the text we already have. So we're going to do player name equals to Bob the hero. All right, so now we have this name. And when we do this, it means that whatever was in a variable before is cancelled, and now it has this value in it. And later on, when we want to use a variable, we can simply refer to it. For example, we can do debug log, and this will debug message into a console, and simply we're going to type player name. If we want to add some text to it, we can do something like plus started the game, right? This is a simple example. Let's save it. Let's go back to Unity. Over here on the player, we can see Bob, but we know we're going to change it when we start the game. Let's go to play mode. You can see player name is adjusted over here, Bob the hero. And in the console, we have message, Bob the hero started the game. So that's how you declare and use variables. Of course, we're going to use them a lot. There is no doubt about it. This is just a simplest example, so you have a bit of understanding how we manage different data. Now, you should know that there are 4 main types of variables that we're going to use. There is actually much more than 4, but these are the basics, all right? We also have public, int, and let's say it's an age. It's going to be 25. And by the way, you don't have to give value to a variable every time you declare it. You can keep it empty as it is, and then it will be 0 by default. But let's do 25. And just so you remember, I'm going to do this box variable called age holds the number 25. Yeah, so you already know that string holds the text and integer can hold the whole number that is not divided in any way. Simple example would be 1, 15, 17, 13, 12, and so on. This can be used when you want to store information about coins, for example, right? You cannot have 2.5 coins. You can either have 2 or 3 coins, or how many lives player have at the moment. Then you would say life count equals to 3, and you can have 3, 2, 1, 0, but not 2.5. And when you need number with decimal, you use float. Public float, and let's say it's going to be move speed. And let's say it is 2.5. When you have a float value, you should put f after it. This box variable called move speed holds the number 2.5f. And you should know that if you try to use data of a different type in the variable, it's going to give you an error message. As example, let's try to give 25.5 over here. And you can see it is underlined. So it's kind of difficult to make mistake with this because program will always let you know that you're doing something wrong. In this case, it says that cannot convert type from float to integer, right? And we have to do just 25. Same with a string over here. If you try to put number 5 over here or longer value, you're going to see it's underlined and it says cannot convert from int to string. It's supposed to be a text here, but if you put quotation marks like that, then it will be text. It will convert the number to text, and Unity will read this information as a text only. Just this text contains 55555, right? Let's call it Bob the hero. And let's remove these 2 lines of code from the start. And last type of variable that we're going to use a lot is called bool, public bool. And let's give this variable a name. Maybe it can be called game over. It is also known as boolean, but we use short version bool in C#. And a bit of interesting information about this one. It is named after George Boole, a mathematician and logician who created Boolean algebra in 19th century. He is the guy who developed Boolean logic, the ones and zeros. Thanks to him, modern computing and programming is possible. And this value can have either true or false value. If you don't change anything here, it will be false by default. If you type here true, it's going to be true by default. Yeah, something like that. Now, if we save this and go back to Unity, you're going to see that there is a checkbox like that defines if it's a true or a false. And this can be used for many cases in game development to define if game is over, if player is dead, if you have the key to the door, and so many other uses. Over here you can see you can use numbers with decimals, and with the int value we had, you can only use whole numbers. And for the text, you can type whatever text you want. All right, so these are 4 types of variables, and we're going to use them a lot, as well as the others. Quick example, just like in the last video, we had variable of a type rigid body. You remember? RB. And this one can be a variable as well. You can assign it in the inspector, like that, and then refer to it whenever you need to. All right, so this is good. Now you know a little bit about variables and you know how to declare them, and you even saw a couple of cases of how to use them, and we're going to discuss them more. But before that, we're going to need to discuss execution order of Unity, which we're going to talk about in the next video. Now, before we end this video, please try to answer this question quickly, and I want to ask you how to declare a variable. Maybe you could declare any variable of any type and give it any name and any default value. Try to do that, and I want to remind you that you need access type, the type of a variable, and a name, and as an option you can give it default value if you want to. Thank you so much for paying attention, and I'll see you in the next one. In this one, we're going to discuss something very important. We're going to discuss life cycle of Unity, because I need you to know how Unity runs the program before we write any behavior for the player. I want you to understand how code is executed. All right, so let's save this for a second. Let's minimize the program, and let's create a new script. I'm gonna call it example. All right, so we've got an empty script, and you can see it has start and update. Start and update is a part of functionality that we have inside of MonaBehavior. And MonaBehavior itself is a base class that allows script to work as a component on a game object. If you don't have MonaBehavior in the script, if your script does not inherit from MonaBehavior, you will not be able to attach it to Unity. And in general, for Unity, this class will be just as a random piece of code that is not attached to Unity in any way. As experiment, let's try to comment this out, save the script, and go back. Now we're gonna choose the player and try to drag example script over here. And you can see we cannot do it. And opposite as it was with the player, now it cannot be attached. It even says that scripts need to derive from MonaBehavior. Now let's go back to the script and uncomment MonaBehavior over here. So MonaBehavior runs Unity's lifecycle. And this lifecycle is quite complex, but with practice, it's very easy to remember, and soon it becomes just another tool you're using to make a video game you want. Let me quickly show you how execution order of Unity looks. For that, we can type Unity execution order. I did misspell it, but it's fine. It's gonna find it anyway. Yeah, I'm gonna click the first link over here. And if you scroll down, you're going to see there is entire cycle of Unity we have here. And it might look quite complex if you see it for the first time, but you don't need to worry about it. First of all, you can make video games without knowing it. Really, you can. And we're going to use most of the things here, and you're going to learn how do they work. It's not going to be a surprise for you very soon. You can see there is start, and that you've seen before. You can see there is update that you've seen before, and you can see there is much more to that. There is late update, and there should be fixed update somewhere. Yes, it is here, and so many other things. And we're going to talk about them and use them later on. But as of now, you don't need to worry about it. I just wanted to show you the entire structure so you know there is much more to that than just start and update. But again, start and update is really enough to make video game, honestly. The most common one we're going to use is awake, start, and update. Awake is called once. After awake, start is called once. And then update is called every frame. To see that, let's simply debug a message over here. Awake was called. Then let's do debug log. Start was called. And then do debug log, update is called. Let's save this and go back to Unity. Over here, I'm gonna make, let's not make empty object, let's use platform for this. Because if you want script to work, you need to attach it to the game object. Let's attach it, and let's go to play mode. Now in the console over here, you can see update is called all the time. If you don't like how it's flooded over here, you can click collapse, and now you're gonna have awake was called once, you can see number 1. Start was called once, you can see number 1. And update is called all the time, and you can see that. And usually when you want to maybe find a component or just find another object that you're going to use in the script, you do it in the awake over here. Then when you need to maybe set default value or initialize something, maybe create a bunch of enemies that player is going to fight, you do that in the start. And in the update, you would check for the input of the player or updates on the cooldown of the skill or any other thing that you need to check all the time. Basically, continuous process should be checked in the update. There is also fixed update. Yeah, and it runs much slower. By default, it runs 50 times per second. If you want to adjust it, you can go to Edit, Project Settings, and find time over here, and you can adjust value over here. But we're not going to do that. It's not that important. The reason I'm talking about this one is simple. Fixed update is used to do some physics calculation. Usually if your game heavily relying on physics, you do calculation of velocity or anything else in the fixed update. The reason is very simple. This one has fixed time step, and as we already know, it runs 50 times per second. So if you adjust velocity and frame rate of your game drops a little bit, it doesn't matter, because this one runs 50 times per second and it's gonna run 50 times per second, and calculations on the physics will be the same. But if you do calculation of the physics of any object in the update, you can have a drop of FPS or an opposite. It can be higher on this particular computer. For example, if you make it move 1 meter per frame, then computer with 50 FPS would make character move slower than computer with 240 FPS. This is how it was in Fallout 76, by the way. People who had faster computer moved faster on the map. This was a mistake that they made. So that's why for anything that you should constantly check and have newest information possible about state of the game, you should do it in the update, right? If you have some calculations you need to do for movement, you should do it in the fixed update. That's the general rules for it. But there are some exceptions to this, and we're going to have such exception in our project. You can set up movement of the character in the update, not in the fixed update, if you handle movement directly based on the player input, because then the velocity of the character would be overwritten each frame, and it would not depend on the physics calculation. But those are details that are not really important right now. I'm just trying to say that there are some rules to programming, but there can be exception. It always depends on what you're trying to do and what is your goal. There is no strict way to do something. You can be flexible. You can use things as you want, because programming is a tool that you use to achieve the goal you want. If I somehow confused you just now, please don't worry about it. Just know that awake is called once, and it's called first, then start is called, then fixed update is called with a fixed time step, and then update is called every frame. Okay, this is good. Now let's delete the example script. We don't need it anymore. And we're gonna write some functionality for the player, but in the next video. As of now, just give me a simple answer to this question. How many times awake is called and when? How many times start is called, and is it called after or before the awake? And how many times update is called if FPS in your game is 120. Okay? All right. I forgot to delete this component of the game object in the last video, so let's do it. And now let's go to the player script. In this video, we're going to discuss functions. So what is a function? Function, or we can also call it method, it's two different names for the same thing. So function is a reusable block of a code that performs a specific task. You already have functions on the screen. We have awake, start, and update. But these are built-in Unity functions. And we can also create our own functions to organize and reuse the code. Functions essentially help you to follow the dry principle. Let me type it. Dry, which means don't repeat yourself. Because when you're repeating yourself, it makes your code unreadable and really, really messy. A real life example of function. Imagine your friend is calling you and asking you how to make a sandwich. And your friend is like, hey, how to make a sandwich? And you tell him, well, you take the bread, you put the butter on, then you cut the sausage, you put the sausage on, then you cut the cheese, you put cheese on, then you put it into oven for 5 minutes, then you take it out and you eat it. And your friend is like, okay, nice, thank you. Then he calls you again. Hey, I want to make a sandwich. Tell me how to make a sandwich. You go over again. You cut the bread, then you put the butter on, then you cut the sausage, then you cut the cheese, then you put it in the oven, then you take it out. Your friend is like, okay, thank you. Then he's calling you again. Hey, how to make a sandwich? And it's really, really annoying, right? It's extremely tedious. So instead, you could write instructions on a paper as a recipe, and essentially you could make a function. So next time your friend calls you how to make a sandwich, you are like, hey, here is the recipe, just follow the recipe. It's the same here. Let's say we would want to display information about player. I'm assuming we have another variable over here, character level. Let's make it more about video games, right? So character level is 80. And we want to know information about player for any reason. So we go to awake and we do like debug log, player name is, and we add player name information over here. Then we do debug log, player age is, and we do plus age. And then we want to debug log, player level is plus character level. So we do have information about player. And if we save it and go back to Unity, we're going to see that in the play mode, we have this information that is printed by the awake. Now, next time, we want to display this information again. For whatever reason, we want to do it in the start. Then, like the first step I want to take is just to take the script, copy it and paste it in here. And it can be done twice. It's fine. But imagine you need this information in another script on a player manager, or you need this information when you try to damage the player. So you already copy these 3 lines of code 4 times, and it already sounds messy. So instead, you can make a function for this. Let's make private void get player info. And instead of doing this, you can have this code inside of a method. By the way, you can see function is not highlighted. It means it is not used anywhere and it's not called anywhere, and it's just there is unused code. But when we use it, when we call the function, and let's do it in the awake, like that, it is highlighted now. And you can even check where it is called, which is also helpful when you're trying to debug something. So now we have a function, and if we want to display info twice, we can just call the function again, like that. And this helps us to organize the code and not repeat ourselves. Now, if I go to play mode again, and we have the same messages, but twice. I know player's info with the name, age, and level is really silly example, but later on we're going to have things like damage function, where you calculating the damage, then you find in an enemy, and you apply damage to the enemy. And that function would look something like this. Oh, actually, let me quickly find the example. So this is script from another project I made. It's a tower defense course. And inside over here, somewhere below, we have a take damage method or damage enemy, something like that. Let me find it. Yeah, take damage. And inside of this method, we calculate current HP. Then we do current HP minus damage. We check if enemy is not dead yet. Then we clarify that it is dead right now, and we call die method, which later removes enemy from the game. And as you can see, we did a bit of a calculation over here. And it's much easier to just call take damage method when we need it, instead of writing all of this every time we need this functionality. As you can see, I did need it 9 times. So otherwise, I would have to type this code 9 times in 9 different places. And it would be same for every function. So that's why we're using function. This helps us to organize and clarify the code and reuse the code we used before. Now, you probably noticed that there was value in the parentheses over here. And that's what I want to talk about next. Let me remove this method. And let me make a new one. Let's say, well, actually, take damage was a great example. So let's make another variable. Let's make public int current HP, which means current health of the player. And we have take damage method. Let's remove all of this because it's getting messy. And let's make private void take damage. So sometimes function can perform an action, but it needs to know additional information, like take damage. We can subtract damage from the current HP, but we don't know what is the damage. In those cases, you can use parameters and pass them into parentheses for additional information. As example, we want to pass int damage into this function. So now when you call this function, you can do current HP equals to current HP minus damage. Just that. Now, when we call in this method, and because I don't have any other functionality, I'm going to use start, I can call the method and I can pass the value over here to define how much of a damage player should take. Let's say 25, right? And default HP is 100. Let's save this. Let's go back to Unity and see what happens. We have a player with 100 HP, and when I start the game, you can see now player has 75 HP because player took 25 damage. And in this way, you can pass different parameters into the function when you need something. For example, now we just did damage, but there may be cases where you need to add a crit chance or armor or so many other information that can be used inside of a take damage. And in those cases, passing parameters into a function becomes very useful, right? This is a great example. All right, so now I would like to say that there is a lot more to functions. There are different types of functions and multiple ways of using them. But for now, we don't really need to clutter our head with all of that. Let's keep it simple. When the time comes, we'll definitely dive into functions deeper. But as of now, I think this is just good. Now, I want to go to the next video so we can finally apply our knowledge on practice. I want to make movement for the player. So let's remove the extra things from this script that we're not going to use. And to be honest, I mean almost everything. Actually, we can just remove everything. Let's remove it, save the script. And before you close the video, try to answer a simple question. How do you make a function and why do you need a function? Okay? In this one, we're going to set up movement of the character. For that, we need to go to the player script. Let's open this. And there are a couple of things we need to know to make movement of the character. And we're going to start with the input of the player. For the crash course section, we're going to use old input system. And in the main part of the course, we're going to use new input system. For those who never heard about old input system and new input system, I'm just going to say that don't worry, old input system does not mean it's bad. It just was made before the new input system. And they both can be used to make a video game. Just old input system suits better when you need to make something small or quick, or when you need to test something. And opposite to a new input system, you actually need to do a bit of a setup inside of Unity to use it. And we're gonna do that in the main part of the course. But as of now, let's use something simple that will help us to do what we want without an extra effort. Okay? So when you're making movement of the object into this space, you adjusting its position on X and Y. Doesn't matter it's enemy or player, you always just manipulate X and Y position of the object. In our case, we have side-scrolling RPG game. So when we want to set up horizontal movement, we need to adjust position of the object on the X. If we want to make a jump, we need to adjust position on the Y and make it bigger. If we want player to drop, we need to adjust position on the Y and make it fall by making Y negative. Essentially, this is how it works. And you can adjust position of the object in many different ways. You can change like the position itself, the X position with the help of script, or you can adjust velocity of the rigid body, and that would move the object according to the velocity you have. It always depends on the approach you're taking, and there are multiple approaches to this. We're going to be modifying velocity of the rigid body. This is my favorite way of moving objects, because in this way you have responsive and natural movement, and you don't need to take care of things like gravity and mass and so on, because rigid body and Unity does that for you. You only need to modify velocity, and everything else can be done by Unity. So yeah, this is what we're going to do. Our goal is to adjust velocity of the player to make player move to the right or left. So to make player move to the right, we simply need to increase velocity on the X. If we want to make player move to the left, we need to reduce velocity, but by saying reduce, I mean make it negative. If you have -5 velocity on the X, it's gonna move to the left. And to do that, we need to know direction we want to move in. For that, we're gonna use input from the keyboard. Let's define a public float, and we're gonna name it as X input, which essentially means horizontal input. Then in the update, we can assign value to this X input. And instead of manually writing some number like -1 or 1, we're gonna read input from the keyboard with the help of old input system. Let's type input, get axis, horizontal, like that. Now, this is all what we're going to do for now. Let's save it and let's go back to Unity. All right, so now you can see in the player, we have X input value and it is 0 by default. If we go to play mode and try to use arrow keys on the keyboard, oh, wait a second, we need to stop this. Let's go to platform and remove rigid body from it. Okay, so once again, you can see it is 0. If we use arrow keys on the keyboard, or if we use A and D keys that you usually use for movement in shooter, for example, you're gonna see how value is changing over here from 0 to -1. And while you're holding it, it is -1. If you release it, it goes from -1 to 0. If you press D on the keyboard, it's going to go from 0 to 1. And if you release it, it's going to go from 1 to 0. This will help us to define direction of the movement when we're trying to move the character. The only thing is that I want to take care of right now is to change it from get axis to get axis row. The difference is very simple. Just now you saw how value was changing from 0 to 1 gradually, right? But I want to have it either -1 or 1. Basically, I want to have snappy controls, so character immediately has its maximum speed instead of speeding up slowly. So we're gonna go and type here get axis row. Now, if you save it and go back to Unity and go to play mode and try to press left or right, or either A and D, you're gonna see it's becoming -1, 0, 1. This will make movement more snappy and responsive, and I think it's better that way. Now, this was just the input, but we also need to make movement from left to right. So first of all, we want to get reference to the rigid body so we can control it. Let's type here public rigid body 2D, and let's name it RB, like that. I just want to say that to adjust this rigid body's velocity that we have on the object player, we need to modify it somehow. And to modify it, we need to get access to this rigid body inside our script we're using, which is here. So that's why we did create a variable of a rigid body and we give it a name. So now we can assign this variable and make it equals to the component we have over here. Let's save the script, go back to Unity. And now you can see I have RB empty variable, and I can drag rigid body like that. And now inside of a script, when I type RB, essentially I'm getting access to this rigid body over here. Sorry, this rigid body over here. And thanks to that, I can adjust velocity or any other property of the rigid body I have. My goal now is to make the movement. So what I'm going to do is I'm going to change velocity. If you are on previous version of Unity for any reason, you would have to type velocity like that. Sorry, like that. But since Unity 6, it is changed. And now we have to type rb.linear velocity. Let's choose it and then we're gonna make velocity equals to new vector 2, and on the x, we're going to use x input. On the y, we want to type rb dot linear velocity dot y. Now, if you see it for the first time, you might have a couple of questions. First of all, what we even doing here? Well, we get in reference to the rigid body and its own velocity, and we're making it equals to whatever value we want. As I mentioned before, movement into this space is done on a vector 2. That's why we're using vector for this. And by making it new vector 2 with the certain values that we pass inside as x and y, we essentially updating velocity every frame. That's why it's okay to do it in the update instead of fixed update, because we're not performing any like physics calculations at this point. We're just updating velocity and making it the same as the input we have. Right? There's not much calculation going on there. We're just saying that, well, x velocity is equals to either 1 or -1. That's it. So that's why it is okay to do it in the update instead of fixed update. And more to that, because we're doing it in the update, movement is going to feel more responsive. And it's very nice when you have responsive movement in the game where anything could kill you in a second, right? So yeah, this is what we're doing here. Now, last thing I want to discuss here regarding vector 2 is its x and y value. X value is the input we're doing from the keyboard. We discussed this before. Now, why am I passing rb.linearVelocity.y instead of, let's say, 0? Because I need to change x, but I don't need to change y, right? I could just type 0 here. Well, that is actually wrong, because if we pass 0, we're setting velocity of the object to 0, and that means object would try to maintain 0 velocity on the y, essentially try to float in the air, but it also has gravity, and because of that it would be pulled down, and we essentially would resist the gravity we have on the object. But if we type rb linear velocity.y, it means we essentially keeping the velocity of the y unchanged. It's like basically saying, hey, rb velocity, now you have x velocity according to my input, but y velocity keep the same as you had before. Now let's save this, let's go back to Unity and see what we've got as a result. We're gonna go to play mode, and I have my player, and I can move to the left, and I can move to the right. Perfect. And now we know how it's working, which I really like. Now, this movement is obviously too slow, and we would like to make it faster. For that, let me move this player above over here. Okay, yeah. For that, we want to have move speed. Let's make another variable over here, public float move speed. And let's make it equals to 3.5 f by default. All right. Now, when we update in velocity of the rigid body, we're going to use x input for the direction, because that is -1 and 1. And then we're going to multiply it by move speed we set in the script or in the inspector. Now let's go back to Unity. And let's hit play button. And now you can see this object moves faster, which is really nice. If you want it to be even faster, you can increase the value and it's going to move like that. The speed of the movement depends on your design here. Yeah. Now, before we finish this video, let's do a bit of a cleanup in the player script. Even though now it looks okay, later on we're going to have much more code in here. We're going to have more variables and more functionality. And we cannot write everything in the update and leave all variables exposed, because it will make mess in the inspector over here as well. To show you what I want to clean up, first I want to talk about access type. We made all variables public here, and that was done for the sake of easier explanation, because when you make variable public, it will be visible in the inspector over here. But usually you should not do that. Usually you should make things private, just like so. Let's go to X input and make it private, because we don't need to see it, we know how it works, we can just hide it. So if you make it private, it will not be visible in the inspector over here. We cannot see X input anymore. But that is not only difference between public and private. You can think of public and private as who is allowed to see and use this variable or function. Public means anyone can see and modify the variable. Private means only this script is allowed to see and modify the variable. And general rule of thumb is to make everything private unless you have a really good reason to make it public. You're going to see practical use of private and public during this course, but as of now, you just need to remember this. You should make everything private unless you really have a good reason to make it public. Reason for that is very simple. First of all, it is better control and maintains. If you have everything hidden, you basically assign variables to a certain script. And if you make it public, any script can get access to that. It can make a really huge mess in your project. You could even accidentally modify the variables from outside of the script, or you could do it not by accident. You can just do it for your own convenience because it's much easier to get public variable and change it when you need to make some functionality. But in the long run, it messes with your project and makes it very difficult to maintain. So yeah, in order to keep your project clean and avoid as many bugs as possible, make everything private. And let's do that. Let's make move speed private, and let's make rigid body private. Now, when I'm going to save it, of course, you understand that it will not be visible in the inspector over here. And now we do not see anything. And you might have a reasonable question. How do I assign rigid body? How do I change move speed now? Well, rigid body is a component on the game object. And for that, we have special functionality. Let's open an awake method over here. And then we can make RB equals to getComponent of rigid body 2D. What it does, when you run getComponent, this script that has this line of code checks components on the same game object that is the script on. So if player is on this game object, it's going to check components that it has on the very same game object. And if it finds rigid body, it's going to assign this rigid body to this variable RB over here. Now, if you save it and go back to Unity and go to play mode, it will not be visible over here, but if you switch to debug mode, you're going to see RB is equals to player's rigid body. All right. Now let's switch on the debug mode. You should enter debug mode only when you need to check something, but other than that, keep mode normal. And let's go to the player script. We need to adjust something else. There is a move speed that is also hidden and we cannot see it in the inspector, but we want to be able to modify move speed. Well, for that, you can go ahead and open square brackets and type serialize field. And you can see it says force Unity to serialize a private field. When you do that, you still keep variable private with one exception. Now it will be visible in the inspector. So at the same time, it is private and visible in the inspector, and you can modify it as you like. In this one, we're going to discuss simple decision making, and with the help of decision making, we're going to make a jump for the player. You probably heard about if statement before. It's very easy to understand. You write an if, and then in the parentheses, let's go to the script. You write if, and then in the parentheses, you write a condition. Then you open curly brackets, and inside of curly brackets, you can write what is going to happen if condition is met. For example, you could display information. Other use to that is you can make player jump if button was pressed. In a second, we're going to use an old input system to test this out. But before we do that, let's quickly do a sidestep and discuss how old input system works. It's actually very easy and simple to understand. We can use if statement to check this out. Let's type if input get key, and we can type key code, let's say Q. We're going to do debug log someone holding Q key, like that. So let's discuss what is happening here. Get key returns true while user holds down the key that we wrote in the parentheses. In this case, is the Q key. And if condition is true inside of this parenthesis, we're going to perform anything that is inside of curly brackets. And basically, What we're doing here is if someone holding the Q key, debug message someone holding the Q key. Let's go ahead and try this out. Let's go back. And I'm gonna go to play mode and press Q on the keyboard. I'm holding it, and you can see it says someone holding Q key. Once I'll stop it, there is no more debug messages. So this is how if statement works. If condition is met, you do something. And this is how input get key works. And this is how get key works. It returns true when somebody is holding the key. You can also have get key down, which we're going to use for the jump functionality. Let's type here, someone pressed Q key. So this one will return true when somebody just started to press the button. Let's go back and hit the play mode. And once I touch the Q on my keyboard, we're going to see a message in the console. Someone pressed Q key, right? Immediately. So this one is the best for immediate response when you have controls of the character. And last one you should know about is get key up, which I honestly never use, I guess. So get key up is called when somebody is releasing the key. Right? You can put your mouse here and says returns true during the frame that user releases the key. So when button is not used anymore, it's going to show you a message. That means I can press the key, there is no message, I can hold it, there is no message, and when I stop pressing it, there is a message someone released the Q key. So these are basics of the old input system. In our case, we want to use get key down, and we're going to do key code space to perform the jump. And we're not going to use debug message, you already know it works. Now let's make jump functionality. I'm going to remove this, and to adjust velocity of the object and make it jump, we need to know how high it should jump. So let's make serialize field, private float, jump force, and let's make it equals to 8. Now back inside of if statement where we check if somebody pressed the space key, we're going to do this. rb.linear velocity equals to new vector 2. X velocity will be unchanged, so we use linear velocity.x, and y velocity gonna be changed with a jump force. Now whatever velocity it had before will be adjusted by the jump force we assign over here. Let's save this and let's go back to Unity. Now when you go to play mode, you can see you have jump force 8 and gravity scale 5. And if you press the space key, it's going to jump like that. Short little bounce. You could increase the jump force, for example, to 25, and it's going to feel like that. Or you could set jump force to 8 and reduce gravity scale to 1.5, and it's going to jump like in a more floaty way, right? This depends on your design and idea for character controller. But I suggest you not to adjust any values until we have visuals of the character, until we have animations, because then it will be much easier to get the idea of the feeling you want to have from a character controller. Now, there is an obvious issue with the jump we have at the moment. If I press jump many times, basically I will be able to fly. We're going to solve this problem, but a bit later on, because this should be solved with a collision check. We're going to check surroundings around the object and check if object stands on the ground when it tries to jump. That will be achieved later. As of now, please just ignore this behavior. Now, I want to talk about cleaning up the code a little bit, because we have functionality, it works, we can go further. But I want to do something here. First of all, I want to explain two things about if statement. There is also such thing as else if, in which you can write alternative condition and then perform something. For example, in this case, alternative could be another input from the keyboard. Input get key down, key code, and up arrow. And you could, I'm sorry, give me a second. And then you could perform jump as well. This is what you can do when you want to have a logic within one function and you need an alternative condition to do something. There is also an else statement that does not require a condition. It should be always written in the end of if statement. And here you could say something like nobody is pressing jump. Yeah, this is quite important, but as of now, not that much. So I just want you to be aware that there is also else if and else, but we're not going to use it right now. Another thing I want you to know, let's remove it. Another thing I want you to know is that when you write an if statement, you can skip writing curly brackets, but only in case you have one line of code inside of if statement, just like we have over here. Now, let me copy this. If I write this if statement like so, it will work and it's going to be the same. These two are essentially same. If you have another line of code, for example, Yahoo! Here, now it is not considered as part of one if statement. What you write here is not important. Important what computer sees as the result. And as a result, this is what computer sees. Debug log, Yahoo! Computer considers this message as a line of code outside of if statement. If you want to include it into if statement, then you need to write curly brackets like so. And now computer will see things just like this. I'm telling you about this because personally me, I prefer to skip curly brackets when I have just one line of code. I prefer to do this. But I know some programmers like to keep curly brackets even if they have just one line of code. Depends. Honestly, it's not really that big of a deal. It's just a matter of personal preference. And I'm telling you this just so you know that when I'm writing something like this, I know that I'm going to have only one line of code in the if statement. If we're going to have more than one line included into if statement, we're going to use curly brackets, just like we do here. Okay, now there is something else I want to discuss with you before we go ahead and make animations. You remember we discussed functions a couple of videos ago, and we need functions to make code clean and maintainable. Functions make your system scalable, and this is what we should do over here. The general rule that you can follow to make your code clean is simple. If you can extract something into a method, I want to remind you, method and function is the same. So if you can extract something into a method, you should do it. You should make your code as readable as possible. As example over here, let's make a function, private void jump. And inside of this function, we can write the jump logic. The jump logic that we have is over here. Let's take this line of code and move it down to jump method. Now, obviously, you can see this function is not called anywhere, and we need to call it for it to work. So let's go to if statement and write here jump. And just like that, you already can see that your code is easier to read. Usually, you read in your code more than you write in it, so it should be easy to read. That is one of the main goals you have when you write in a clean code. Now it's much easier. I can take a quick look at the if statement, and it's like if input get key down, okay, what the key is, space, okay, then we do what? We jump, all right. And if I need to take deeper look at the functionality we have inside of a jump, I can go to that function and look at the function and see what it does. Now we should do same for other functions we have over here, such as this one, the movement. Because yes, we know it is the movement, but if you take a quick look at this, it's pretty long and it's quite difficult to understand what it does. Well, it's not difficult, I know, but we're working with the example we have, right? So we need to extract this into a method as well. We could do it manually, just like we did before, or we could use a hotkey. Now, if you're on a Mac computer and you are using VS Code, probably this hotkey will not work for you. If that's the case, just wait a second, I'm gonna show you what you could do to make it work. So you can select the line of code to extract the method and click right button and click quick actions and refactoring. And there is this thin extract method. If you click it again, you're going to see that it actually has a hotkey, Ctrl+dot. If you select it and click Ctrl+dot, you will be able to extract method. What I prefer to click is actually Alt-Enter. Alt-Enter for quick actions. And it has same menu. So over here, I'm going to choose extract method, and I'm going to give it a name, handle movement. Now I have much cleaner update. I have the X input, I have handle movement, and input of a key and a jump. And move functionality is over here inside of this method. Now, let me quickly step aside and talk about extract method for Mac computer. It's going to be real fast. So if you don't have that extract method functionality in your VS Code, you can solve the problem by downloading Visual Studio Editor inside of Package Manager. We discussed this problem with my students a lot, actually. So this is the first step you could take. You go to Unity, Windows, Package Manager, and you search for Visual Studio Editor over here. This may help. Another solution you could do is to check extension OmniSharp. This may help as well. But it's not for certain. For some people, it does not work for some reason. So if it does not work for you, please don't worry about it. It's not like the end of the world. You can still make functions manually. Really, it's not that big of a deal. Let's make another function to make this cleaner, and we're going to go to the next video. We're going to do private void handle input. And inside of handle input, we can handle input of the horizontal movement like that, and we can handle input of the jump functionality. If input was done, perform jump. And just to make sure all of the input is working, we need to call it in the update. Handle input. Now we have a good structure that we can modify and improve. In this one, we're going to take care of the visuals of the player, because I think it's time to get rid of the white circle and replace it with an actual character. To do that, first of all, we need to get the visuals, the asset pack that we're going to be using for Crash Course and for the main part of the course as well. For that, we need to go to the website that is called itch.io. This is how it looks. If you never heard about it, you should know about it. It's a very good website where you can find asset packs for your video games to practice, or just to make one video game if you want to. It is available over here. Browse assets. There are free assets and paid assets, and there's just like hundreds of them. There is also games that you can see, the games that were made by other indie developers. And also it's a good spot if you want to publish your first video game as well, because this is not just a website. Essentially, it's a huge community of indie game developers, and you definitely should have an account here. Now, what we're going to do is we're going to get an asset pack that is called Warrior. For that, we're going to go over here and search for it, Warrior. And then scroll down a little bit over here. If you cannot find it, I'm going to attach link to this lecture and you can download it from there. This asset pack has lots of animations in it, and it will help us to develop lots of good things and learn a lot about game development. If you want to use different character other than this one, you can do that, but I highly recommend to stick to the same asset pack as I am using, because this way you will have easier time following the course and it will be easier to learn things. Otherwise, you will have to not only learn, but adapt changes to your character, and with the time it will be harder and harder to follow up. So it's better to stick to the asset pack I'm using, so you can learn everything, and then afterwards, once you know how it works, you can make your own project with your own character. Okay? Now, we're gonna go ahead and download. Over here, payment is optional. If you would like to support creator of the asset, you can, but if you don't want to, you just click no, take me to downloads. Then over here, you're gonna go download, and then we're going to open the archive. Inside of the archive, you have the folder, and over here we have license, contact, you can read it if you want, and then there is a sprite sheet over here. This sprite sheet contains all animations combined together, and this is what we're going to use. There is also another folder, individual sprite, and over here you can see animations are divided to different folders. But I think we don't need that many files in our project, and we can just simply take this sprite sheet with visual effects. Let's drag it over here, and let's change name to player graphics. All right. Now what we want to do is to take don't worry about these names, they're going to be changed in a second. Now we're going to take one of the sprites and apply it to the main character over here. Before we do that, I need to explain something to you. Over here we have a sprite renderer component that is responsible for the visuals of the player. And we could simply drag the sprite over here and it would look like a character. But it's not the best practice. With experience, I learned that it's better to have logic and visuals as a separate game objects, so you can do something to one object without affecting another object. Because of that, we're going to remove component of a sprite renderer, and then we're going to make empty child object under the player game object. Let's create one, and let's call it Animator. And it will help us to set up visuals and animations of the player. We need to add sprite renderer, and then we need to drag one of the sprites over here. Now it looks like a character we downloaded, but it is very small, and there is also a couple of another issues that we need to take care of. First of all, let's go to player graphics and change pixel per unit to 16. Apply. Now it has normal size. Another issue, it is blurry and we cannot see anything, right? Let's go to compression, click none, and filter mode, no filter. Now when you hit apply, it's going to be crispy and sharp. Very nice. Another step we need to take care of is cut the sprite sheet. Let's go to sprite editor over here, and you can see they were cut, but in a very strange way. Basically, each sprite has different size. Because of that, when you try to animate the character, it will do jumping from one point to another. As example, let's do this. I'm gonna take my player, place it over here, and I'm gonna replace a sprite on the sprite renderer from this one to this one. And now you look how character, instead of standing on one spot, will basically teleport to the left a little bit, right? And this is a glitchy behavior. We cannot have that in the game. So we need to go ahead, let's set it back to 0, and we need to cut the sprite sheet so it has same pivot point on each object. What is a pivot point? I mean on each sprite. So what is a pivot point? Pivot point is very easy to understand with this example. Imagine a door. There is a handle and there are hinges. And pivot point is essentially a center point that we use to rotate the door. When you open the door, it should rotate around these hinges over here, not from the center of the door. And it works like that for every object in Unity. You should know around which point object is rotating and with which point you're trying to center the object. So to make it all correct on this spreadsheet, we're gonna go here and click grid by cell size. On the X, it's going to be 69, and on the Y, it's going to be 44. Let's click slice. Yes. And now we can see all of them having the same size, and pivot point for all of them is at the center. Let's click apply. Now let's test this again. We're going to select Animator, give it player graphics 0, and let's place it like so and see what happens when I'm replacing the sprite with another one. Because essentially that's what we will be doing for animations. We're going to be replacing sprites on a sprite renderer. Let's say I'm taking this one and placing here, and now it just looks like character is attacking and it's not teleporting anywhere. So that was the point of doing it. Now let's set it back to 0 and take care of something else. When we select in player, we can see center point is above the head. If it's different for you, you go over here and make sure you check the pivot as a center. If you select the center, it's going to behave differently, and that is not exactly what we need. We're going to go ahead and work with pivot. So again, difference between pivot and center is very simple. The door with hinges, pivot point is over here and center is over here, and we want to work with pivot point. Okay. So what we need to do now, we need to place character in the center of the object. The visuals, actually. We need to place visuals in the center of the object. If we don't do that, if we do something like this, when we try to respawn the character, let's say your respawn point is over here, and you respawn the character with the center, it's going to appear on the right of the respawn point. If you try to flip it, we're going to do flip with the rotation so it can look to the left, it's going to teleport as well, which is not okay. So what we're going to be doing is trying to center the character. And actually, I know the values that will help us. You take the animator, set 0 on the Y, 0 on the Z, and 0.5 on the X. Now, when you select player, you're going to find that the center is approximately in the center of the visuals. And that is perfect for us. If you have different visuals, you will have to adjust it by yourself, okay? Now, let's change the collider, remove circle collider, and add component of a capsule collider to D. Go closer and click Edit Collider over here and increase the size so it has shape of a character. I think this is perfect. Nice. Now, we do have a couple of issues with the character before we even make an animation. I want to show you them. Let's go to play mode. And first, when you try to move, your character falls. We can fix that easily by taking care of freeze rotation on a rigid body over here. If you don't see it, open constraints and click freeze rotation. Now when you try to move again, it's not gonna fall, it's gonna move. Another pretty noticeable issue is that when you move into the right, it's okay, but when you move into the left, character moving with its back, and it's supposed to look to the left when it's moving to the left. We're going to take care of this, but later on. As of now, we're just working with animation. So I just want you to know that we will be fixing it, but later. As of now, just ignore it, okay? As of now, we're gonna move like that. Very nice. All right, so we did prepare a character for animations, and it has Animator game object with a sprite renderer. Now let's add component of Animator. And Animator will essentially run animations that we choose. And when it's running animations, it's going to replace sprites on a sprite renderer. For Animator to work, we need a controller. So let's make one. Animation, Animator controller. And let's name it player. Then choose Animator and drag it over here. Next step, we go to animation window. If you don't have it, you can find it over here under the window, animation, animation. So you select Animator, you click create, and we're gonna make new animation. We're gonna use camel case here, and we're gonna type player idle. This will be the idle animation. Now it is empty, and we need to give it a sprite so it can work. Let's expand the sprite sheet and choose idle animation. First 6 images. Like that. Now if you play it, it's going to be very fast. So we need to change sample rate to make it slower. If you don't see this over here, you go here and click show sample rate. Let's try 10. Okay, this works for me. I like it. It's already feeling like character is alive, and that is very good. If you select Animator and play animation, you're going to see how sprites are changing over here, and that is done with the help of Animator. And on the Animator over here, we can see we have idle animation, and it is default animation. This window is essentially showing you what is inside of this Animator with this Animator controller. Okay. Now, believe me or not, this is good for this video. We also want to set up movement animation and transition between animations, but we're gonna do that in the next video. As of now, let's do a bit of a cleanup and go further. I want to make a folder for animations. And we're going to take animation and controller and animation and drag them to the folder, like so. And let's make another folder for graphics. Or actually, you know what? We're going to be using this sprite sheet a lot, and I don't want to go to the folder to choose it. So let's keep it here for now. Okay, so this is how we're going to have things. Now we have player with idle animation, but if you move, there is no movement animation, so we have to fix it. In this one, we're going to set up a movement animation, and I want to show you how to set up transition between animations. We're going to start by making the animation itself. So we're going to select animation window, select animator, and then click over here, create new clip. Let's go to animations folder and name it player move. We're going to save it. And now we have empty animation, and we need to give it sprites to animate them. Let's select from this one, which is graphic 6, up to, I guess, up to this one should be fine. Let's give it sample rate of 12. And I know sample rate value because I did work with these assets before. I have a bit of experience with them. If you like, you can try different values here. So this is how it looks when it's running. Let me see if we should add the last one over here, like that. Oh yeah, it makes it a bit better. Let's use it. So essentially these 8 sprites. And now, if you go to Animator, over here you're gonna see you have player idle and player move. And you can use these to show when player is standing and when it's running. Let's go to parameters, and over here to control transition between animations, we can use different parameters: float, integer, boolean, and a trigger. I'm sure you're familiar with some of them because we discussed variables, right? And you can use variables to control transition between animations. We're going to discuss trigger when we will be setting up the attack animation, but for now we're going to use boolean. Let's name it as is moving. Now we're going to go ahead, click right button, make transition to player move, and click this arrow over here. Condition for this transition will be is moving true. Then select transition back. It will be is moving false. Now let's go to play mode because I want to discuss settings over here. You can see player is standing. If I click this over here and make it true, it's going to be running. If I uncheck it, it's going to be standing. The only issue you could notice here is that it has a bit of a delay. Look at this. I'm clicking it. There is a bit of a delay and then it's running. I'm clicking it again, a bit of a delay, then it's standing. That happens because we do have exit time and transition duration between one animation and another. And you can see even it is displayed over here, how animation is played. So we're gonna uncheck exit time and make transition duration 0. In this way, transition will be immediate. Let's select another one. Do uncheck exit time, transition duration 0. Now, if I click this checkbox, it's gonna run, stop, run, stop, run, stop. Basically, it's doing it immediately. And this is what we need. Now, our goal is very simple. We need to get access to this animator from the script. And inside of the script, we need to adjust this boolean to make it work automatically instead of us doing it manually. Essentially, what we will be doing is changing this boolean inside of this animator. To do that, we just need to go to the player. We're going to go above over here and declare a new component, private animator, and let's call it anim. Then in the awake, we need to get that component. And you know that this time animator does not sit on the same game object. It is child over here. So to get this component, we need to write anim equals to get component in children, and it will search all children of the object and look for animator component. And it will assign first animator it will find to the anim over here. Now we need to set up that boolean that we checked with the help of the code. You already know that we can declare the variable and we can assign the variable at the same time. This is what we did over here. You also should know that you can make variables locally. Let's go ahead and make handle animations method, and we can see it is underlined because we do not have such method. But if you click Alt-Enter, you can generate method. And now you have method over here. You should know that you can declare variables locally like that. Bool is moving. And now this variable will be available only inside of this function, and only that. That's why it is highlighted with blue instead of white like we have over here. You cannot use this, let's make it true for now. So you cannot use it here. If you try to type is moving, there is no such thing. It's going to be underlined because this is a local variable. It's not global, and it is available only inside of this method. And as I mentioned before, Boolean can be true or false. And we can make it true if some condition is met. This is sort of a quick if statement. We know that when character stands, velocity is 0. Let's go back to Unity for quick check. Over here you can click Info, and you can see velocity on the X and Y. Let's go to Play Mode. And you can see X velocity is 0. Once I try to move, X velocity is negative or positive, right? So we can use this information to say when we are moving and when we are not moving. Let's go back over here and type bool is moving equals to RB velocity, linear velocity dot x not equals to 0. So if RB velocity not equals to 0, this Boolean is going to be true. Essentially, we're saying this is true if this condition is met. We could make an if statement for that, but that is very redundant, right? We could do this. If RB linear velocity dot x not equals to 0, then is moving true, else is moving false. But you see how much of code is that? Instead, we could just write what I did write over there. By the way, maybe let's do a quick check for this. I'm going to do public is moving, just so you see how it's working. Like that. Wait a second, I made a mess. Public bool is moving. All right, I'm going to save this real quick, just so you can see. We can see is moving is false. Once I try to move, it is true. So we just need to pass this Boolean to the animator, and it's going to be it. Let's go back. And I'm going to delete the global variable and make it as local, because we're going to be using this information only inside of handle animations method to update the animator, and only for that. Now let's take anim and type set bool. This is how you change Boolean on the animator. And over here in quotation marks, you need to use exact the same name as you used when you created a parameter. If you're afraid to make a mistake, you can go back to Unity and copy this from here, Control C, then back on the script, you paste it in here, and then when you set in Boolean, you choose the parameter by the name, and after that you give it a value. You can see it says bool value, and we can simply pass is moving Boolean over here. All right, that's it. Let's save it, and let's go back to Unity. Let's go to play mode. Now, when you try to move, you're going to have transition to movement animation. Very nice, right? I love it. So now we have a couple of things to do at the same time. We need to set up jump animation, and we need to make flip of the character. And also character still can endlessly jump when you press the space key. So we have 3 things to fix. And it doesn't matter in which order we take care of them, really, because they're all kind of important. What I want to start with is the flip of the character. Now, this is how we will be doing the flip. It's actually one of the easiest way. You go to rotation and you change it from 0 to 180 like so. And it's going to flip it. And this is what we need to do in the script. There are other ways to flip the character. You can change the scale. Another one, you can change the Z. No, wait. no, X, sorry. You can do -1 on the X and you can change the scale to flip the character, but I prefer to use rotation. There is also another parameter that we could use. We could flip the sprite over here, but as you can see, it does not really do what we need. It's just flipping the sprite. And our sprite has an empty space on the right. And when we try to flip it with the flip X, it's teleporting the character. So the easiest and best solution here is to use rotation on the Y and set it to 180. Let's set it back to 0. And let's go ahead to the player script and make a flip method. Somewhere below, I'm gonna do private void flip. Inside, we're gonna simply use transform component, and transform component, this one is always available. You don't need to get it. And you do transform, rotate, 0 on the X, 180 on the Y, 0 on the Z. Now, when you call this method, it's gonna flip the character just like I showed you. Another good idea would be to keep track of the facing direction of the character, because we can see it's looking to the right or left, but computer does not know what we even doing. So let's go somewhere here, and below we're gonna make a private boolean facing right. And since our character is facing right by default, let's make it true by default. Then we're gonna go down. Oh, actually, you know what? I want to see this boolean so we know it's working. Let's do serialize field over here. Later, we're gonna hide it. Move it down. And over here, we're gonna do facing right equals to, and here it might look weird, but it's actually the way to do it, not facing right. What it's gonna do is something very simple. It's gonna set current value to an opposite value every time we call the method. Consider it is like a switcher on the wall to switch on and switch off the light. When it's true and you're gonna execute this line of code, it's gonna become false. If it's false, it's gonna become true. And this will essentially help us to keep track of a facing direction. Now let's try to use this method. There are multiple ways to do that, and I wanna show you a trick to test the method. You can type here a context menu, flip, just like that. And now we're gonna save it, go back to Unity. Let's go to play mode. We can see we're facing right by default, and you can click right button and choose flip, and it's gonna flip to the left. And it's not facing right anymore, it is false. And rotation is -180. You can flip again, and again, and again. Now what we need to do is to call this method with a condition instead of clicking it manually with the mouse. So let's go back to player script. I'm gonna remove context menu and I'm gonna make private void handle flip. Now inside of this method, we're going to be checking facing direction and movement direction at the same time. If they are an opposite, means if character is moving to the left but facing right, we should flip the character. This is how we're gonna do it. If RB linear velocity dot x is bigger than 0, it means we moving to the right, and facing right is false, then we not facing right, but we're moving to the right. It means we should be facing right. It means we should flip the character. We're gonna do flip over here. Else, if RB linear velocity dot x is less than 0, so we're moving to the left, and facing right is true, then it means we moving to the left, but facing right, and we should be facing left, so we should flip the character. And in that case, we're gonna do flip as well. And now we just need to call this method in the update. Let's do it. Handle flip and test it. Let's go ahead and see if it works. And sorry, it was too fast. Handle flip over here. And then this is how this method looks. Let's go ahead and test it, and then I'm gonna explain it once more, okay? Let's go to Unity. Let's go to play mode. Now I'm standing, I'm moving to the left, standing, moving to the right, standing. So now we do proper flip of the character. I think this is so good. Nice. Should we make it a bit faster? Let's make it like move speed 8. And let's see this again. Yeah, now it looks more realistic. I like it. Also, I feel like it's too close, so I want to go to the main camera and change size to 8, so it will be a bit further. I think this way it's better. Okay, now let's go back to the method and talk about it a little bit, because I know if you are a complete beginner, this might be a lot. First of all, what is this? It is an AND operator, and you can use it to make multiple conditions inside of if statement. There are a couple of other things like this, and we're going to use them later on, and we're going to practice with them. As of now, just know that we can do something, and something should be true to perform the action after the if statement. In this case, we check in if velocity is positive, if we move into the right, and if we face into the right. And if facing to the right is false, then we should be facing left. So we're using flip method. Inside of the flip method, we do rotation. So we rotate the character, we update the visuals, and then we update the Boolean, not only to keep track of a facing direction, but also so this condition is no longer true and we will not be flipping character again and again. And so next time when we start to move to the left and this one is true, we're going to flip the character again. In this one, we're going to be doing collision detection. The reason is very simple. As of now, when we try to jump, we can jump endlessly, like so. And that is not what we want. We want to be able to detect if the ground is below the character and if we can jump right now, because we should not be able to jump if we are not standing on the ground. How it's going to be done? Well, this is a quite complicated topic if you are a complete beginner. So if you feel a little bit confused by it, please don't worry about it. Just try to understand as much as you can and move on. We're gonna do this a lot, and definitely you will learn more about collision detection with practice. So let's go to the player script. All the way above, we want to make a header. Let's do header. This will help us to make things pretty in the inspector. Let's call it collision details. And let's make one header for movement. Header movement details. Now under this header, we want to make serialized field, private float, ground check distance. We will use ground check distance to try to find ground below the character. Basically, what we're going to be doing is we're going to have an object of a player, and from the center of the object, we're going to shoot sort of like a laser ray, to be precise. Yeah, we're going to shoot a laser down, and if this laser hits the ground, it means we did detect the ground. And we're going to be using ground check distance to define lengths of that laser, right? That's why we need it. And before we go any further, I want to visually show you this raycast so you know how it's going to be working. Let's go below over here and let's make private void on draw gizmos method. Inside of this method, we're going to type gizmos draw line, and we're going to define from where to where we draw in the line. We're going to type from transform position to transform position plus new vector 3, and it's going to be 0 on the x, and minus ground check distance on the y. As for z, we can write nothing, and then it's going to be 0, because if you don't write anything, then it's going to be 0. Yeah, and we don't need z into the game. All right, so what is this? OnDraw Gizmos allows you to visually display information on the screen. Player will not see it. It will not be used for actual physics collision check. It will only draw a line so you can see it. Again, it's not going to do anything except the visuals. You will not be detecting ground with this one. And How it works is very simple. You have transform position, which is the center of the character, and that is where you start the line. And then you set in the second point of the line so you can connect two dots and draw the line. And in our case, we do transform position plus new vector 3 minus ground check distance. Let's say this distance is 5, so it's minus 5. So we take current position plus minus 5 on the y is below, and we're gonna draw a line like that. Now, if you go back to Unity, over here, you're gonna see we have a variable, and you can zoom on the character and try to increase this variable, and you're gonna see a line over there, right? That is the ground check we're gonna be using. Let's do 1.30. Let's do 1.30. Maybe, oh, sorry, maybe 0.4. Yeah, 0.4 should do. Also, now I can see that visuals are not exactly at the center. That's how I feel, but maybe because of the capsule collider. Let me do offset 0. Yeah, so 0 and 0.3 on the offset of the player. And yeah, this should do it. I like it. So what we're doing here, we only drawing the visuals of the line. It is not actually working. If you go to play mode and try to jump, you still can do endless jump. But now that we visually see the line, we can also cast invisible line with the help of Unity and do the physics check. And if you're asking a question, well, why don't we cast a visible line? You cannot do that. That's not how it works. You do the raycast and you separately make gizmos so you can see the raycast. It's essentially two different things with same values. That's how it's working. Let's go. Maybe, I don't know, usually collision is done below. Let's do it below. Let's do it over here. Private void handle collision. And inside of this method, we're going to be checking if we're detecting the ground below. How do we do the check? It's very simple. There is built-in functionality for that. We only need to store that information somewhere. Let's go ahead over here and make, for now, visible boolean. Private bool is grounded, which means we're detecting the ground and we're standing on the ground. Now we need to define if it's true or not. We're going to go to handle collision method. And over here, we're going to make is grounded equals to physics 2D raycast. Then we're going to open parentheses, and you can see we need origin point from where we're casting the raycast, from where we're casting the ray, essentially from where we're shooting the laser. And for that, we're going to use transform position of the character. Then we need a direction of this raycast. And as a direction, we can use vector 2.down. And then we need the distance, and we already have the distance, ground check distance. And then we need a layer mask to define what is ground, because if we're just going to shoot raycast, it's going to detect everything. It's going to detect player, enemies, coins, whatever you have. So we need to specify what we're trying to detect. For that, we're going to go over here and make another variable, serialize field. Private layer mask, what is ground? You go down and you use this layer mask over here. What is ground? Now, this will work, but method is not called anywhere. So let's go to update and call handle collision. And I suggest we handle collision before anything. Let's do handle collision. I'm gonna save it. Now let's go back to Unity. Over here we have what is ground, and it says nothing because we do not have anything assigned. Let's go to the layer, add layer, and type here ground. Now we have a new layer with the name ground. We're gonna go to player and say what is ground, ground. Now next step is very important. Don't forget to do it. Go to platform and change layer from default to ground. And now this platform is a ground. And if we go to play mode, we're gonna see is grounded true. Once I jump, it's gonna be false, false. We still can do the endless jump, we're gonna fix that, no worries. But now let's focus on collision detection. Is grounded false? If you make the ground check distance smaller, you will not be detecting the ground. We cast in the raycast from here, and it should be long enough to detect the ground. So let's do 1.4. Oh, no. Yeah, 1.4. Okay. Very nice. Now we do detect the ground. We know how it looks. We know how it works. Let's go to the player script. And in the jump method, we should be able to jump only if we're standing on the ground. We can do that by typing if is grounded, then apply velocity to the rigid body. Save it, go back, and try again. And now I can see, I can jump, but only if I'm standing on the ground. If I try to smash the button a lot, I will not be flying same as before. Now, since we already have the jump and ground detection, let's go ahead and adjust the parameters over here. Gravity scale defines how much gravity affects the body. And I know that 3.5 is actually a good value for this character, so we're going to be using 3.5. There is also linear damping, which essentially means how how much character feel air resistance. Yeah, this was difficult to say, honestly. Yeah, sorry. So linear damping, it means how much air resistance character can feel. And I want to give it a 0.5, just a small value, so it's there, but it's not affecting us much. And then for the jump force, let's change it to 12. And essentially this is how you make feel of the character controller. You tweak these values and you find what you like. And these values that I like. Okay, so I like how jump feels, but now we need animation of the jump because this is not pretty. We're gonna take care of that in the next video. Before we end this, let's go to player script and clean this up a little bit. Over here, we don't need to see this face in the right boolean. We know it's working. So I'm gonna hide it, and maybe I'll move it over here together with the X input. And we don't need to see if character is grounded. We know it's working, so I'm gonna hide it. These two we need to see because we need to assign them. Lastly, let's go back here again, and I'm gonna go over this once again, just in case. Raycast is a built-in functionality that shooting a raycast from a point to a direction you specify. In our case, we used vector down, so it's shooting direction down. Vector down, if you put your mouse over it, says 0, -1. If you have a vector and it's 0 on the x but -1 on the y, it means it's going down, right? So from a point, we shoot in raycast down, and distance of that raycast is defined over here. And then we specify the layer, so we detect only the certain object. And that result of that raycast can be either true or false, because we either detect something or we detect nothing. And if we detect something, then it's true. And then we assign that true value to is grounded. If we're not detecting anything, this would be false. And then we use this true false to define if we can jump in this if statement. And at the same time, we draw in a gizmo, we draw in a line from transform position to transform position plus negative ground check distance. Essentially, transform position, negative value on the y for the second point. And this is how we draw the line. This only draws the line, this only does the detection. But we make them together so we can see how detection would be done. We just give them same parameters. You can do detection without gizmos, you'll just not see the line. And you can draw the line without detection, but it will only do the visuals and it will not do any kind of a detection. Okay, very good. So already we have quite complicated script, right? So many things here. I guess If you are new, this and this is most confusing, but I'll be very honest with you, there is no way to make it easier. And in this one, we want to set up jump and fall animation. Before we do that, I want to say that if you never did setup of a 2D character, you probably imagine yourself a jump animation that contains frames where character is getting ready to jump, when it's jumping, when it's in the air, then it's transitioning from the air to fall, and then it's falling, and then it's landing on the ground, maybe in hero landing. But in 2D games, usually it's not done like that. Look at this. This is a Mario gameplay, one of the first platformers. Look how jump animation is done. There is basically 1 or 2 frames where he has his hand up, and when character is in the air, we immediately enable the jump animation. It is done that way so you can feel the jump is responsive and dynamic, because when player presses the jump button, player expects the character go up. But if you have a functionality where you press the jump button and then it's getting ready to jump and it's slowly getting ready and then rising up, it does not feel responsive. It should not be like that. There are a couple of other examples you can see on the screen where you can see that the jump is just a couple of frames. This game is a bit more advanced, but still jump is just a couple of frames. So this is what we will be doing here as well. Let's select the animator, go to animations, create new clip, animations, and right here, player jump. Now let's go to animations over here, not animations, graphics, and we need to find jumping images. This is the attack. It's over here. So 41. And we should not choose all of them because some of them are fallen images. Let's try these 4. We're going to drag them to player jump, and let's set sample rate to 12. Let's see animation. Let's hit play, and this is how it looks. Yeah, I think this is fine. The only change we want to do is, no, wait a second. Here she is already looking down, so she is getting ready to fall. So let's remove this sprite from here. This is the jump we have. Now we need another animation. Create new clip. Player fall. And for the fall, we're going to select these 4 sprites. Let's do sample rate 12. Okay, so there is a bit of a transition I can see for the animation, and we could use it, but with the system we're going to use for the crash course, it's unnecessary really. Besides, I'll be very honest with you. It's okay when we look at this right now, slowly, but usually animation is very fast, and you will not even notice this transition over here, even if you add one more sprite like that. I'm telling you, this transition will not be noticeable. More to that, it might feel a little bit glitchy. But you know what, let's just try it out. Let's see. Let's see if it works. Because if it doesn't work, we can always just delete these 2 sprites, okay? I want to see it in the action. So this is the fall animation. Now, let's go ahead and set up transition between these 2 animations. And to do that, I actually want to show you a trick. I want to show you another way to set up transition between animations. And I'm talking about blend tree. Let's create state from new blend tree. And let's name it jump/fall. And let's click it twice. So blend tree can do blend between animations according to the parameter it has. We're going to expand it over here, and we're going to add motion and then add another motion. For the first motion, we're going to choose player fall. For the second motion, we're going to choose player jump. Now let's change the name of a parameter. For this parameter, we're going to be using y velocity for a very simple reason. When character goes up, it has positive y velocity. When character goes down, it has negative y velocity. So essentially, when we go up, we're going to do jump because of the positive velocity, and when we're falling, we're gonna do fall because of the negative velocity. We only need to go to automate threshold and change it from 0 to -1. Now I'm gonna click play over here so you can see the animation, and this is what is going to happen. When velocity is positive, we're gonna be rising up like that. You can see a result over here. When we're falling, it's gonna be done like that. The only issue about this I don't like is that it is cycled, and we can see that movement all the time. So what we can do is go to player fall and uncheck loop time. This is the trade-off for the transition, but we're gonna check how it works and maybe adjust it. Don't worry about that. So now we have a blend tree with a y velocity, and you can see according to the parameter we have over here, animation will be played differently. Thanks to that, we can now adjust this animation simply by adjusting this parameter of the y velocity. We do not have any transition between these two animations and jump fall, so for now, just to test it out, I'm gonna set it as a default animation, okay? And this player jump and fall we already using inside of a blend tree, so we don't need them. Let's delete them like that. And again, we're gonna set up transition between these two. Just wait a bit. Let's go to player. No, wait a second. Let's copy this name over here. And then let's go to player. We're gonna find handle animation method. And over here, we're gonna do anim set float value. Name of a parameter is y velocity, and we're gonna give it value of rb linear velocity dot y. And that's it. Let's save this and let's go back. Now I'm gonna go ahead to the game view and I'm gonna try to jump. We can see I'm looking up, and when I'm falling, I'm looking down. All right. It looks weird because we don't have transition to idle, so I guess we should fix that, and then we can tweak parameters of the jump and fall to make it look better, okay? Now, how are we gonna do transition between this and this? Well, one of the obvious ways would be to transfer to jump fall from any state. That means it would transfer either from idle or move, or set up transition directly from idle and from move to jump fall when we need to. But then we would have to set up transition back. And even just by drawing arrows, for example, I can already see it's making a mess. So I want to make a blend tree for idle and move, and it will be much easier to manage that way. You might ask me, Alex, well then why did you not show me blend tree in the first place for idle and move? And I will answer in a very simple manner. I needed to show you how transition is working just for learning purpose, honestly. Because if I'm gonna do everything I like to do just directly without explaining anything, it might be a bit confusing. So we're gonna get rid of this. Don't worry, delete it. And we're gonna make a new blend tree. And we're gonna name it do idle move. And then go over here and make new parameter, float x velocity. Like that. Then open this blend tree, change parameter to x velocity, and add motion field 3 times. Uncheck automate threshold, do -1, 0, 1. And for animations, we choose move, idle, move. We need -1 because sometimes we're moving to the left and velocity is negative, but we're still moving, so we need to play move animation. Now, if you go to play mode, you see character is standing, and if you drag the slider, it's gonna play move animation, then it's gonna stop, and it's gonna play move animation again. Yeah, you see how easy this is? This is much easier than setting up 2 animations with transitions, right? Now let's go back and let's do this. Let's set it by default And now let's set up transition between these two. And the difference between this, basically a state, and this state is that this one is done on the ground while we're moving, and this is done off the ground while we are jumping or falling. So that could be condition for transition between these two. Let's change it from is moving to is grounded. And let's make transition to jump fall if is grounded false. Uncheck exit time and do transition duration 0. Then from jump fall to idle move, we're gonna transfer if is grounded true. If we're on the ground, we should not jump and fall. We should be idle and move. Uncheck exit time, transition duration 0, like that. Okay. Now let's go to player script and update these parameters accordingly. We're gonna open player script and I'm gonna click this cleanup. And over here, first of all, this should be now is grounded. And value we give it is grounded, the one that we used with the collision detection. And this now is not needed. And also, I guess you know what we should do. We should do anim set float x velocity to rb linear velocity dot x, like that. Look how pretty and clean this is. And honestly, I would love to show you this in the first place because I like how it looks right now. It's so clean and efficient. But we need to go through the steps to learn how things are working before we apply the best solution we know, right? Okay, so let's save this. Let's go back to Unity and see if we have it working as a result. I'm standing, I'm moving, so blend tree is working. You can go inside and check the parameter and how it's changing. So we see it's working. And now finally, if I jump, I transfer from one animation to another. Now, as I mentioned before, you can see that transition is not really noticeable, that one frame. It only makes it glitchy, I would say. So this is what I want to do instead. I'm going to select Animator, Animation, Fall, and I will keep these 3 frames because they are pretty, they are animated, and I'll delete these 2. And on the animation fall, we're going to enable loop. Let me see this again. And yeah, this is better. Let's take a platform. We can press Ctrl D to duplicate, then press T to change and make it big like that. Then take a player, move it here, and see how it looks when you fall in. Yeah, this is so good. I like it. Ooh, whoa, yeah. And even if you walk off the ledge without a jump, you're gonna transfer to fall animation. Nice. You can see there is an issue with character sticking to the wall, like that. That can be easily fixed. Let's go to somewhere here. Make folder for materials. Then inside, let's make material. Call it, no, sorry, not that one. Create 2D physics material and call it sleepy material. Give it friction of 0 and apply this material to either rigid body or collider. Let's apply it to rigid body. Now I'm gonna take this platform, make it bigger. I wanna test the fall animation again. I can jump, fall, I'm falling pretty, and if I try to stick to the wall, it's not working. Okay, we have character controller. In this one, we're going to develop an attack animation for the player, and it will help us to learn how animation trigger is working, and also how to call a function with the help of animation event. Let's go to Animator, Animation, and create new clip. in the animation folder, we're going to make player attack. Save it. Now let's open graphics, and actually there is 3 attacks in this spreadsheet. This is the first one. Then there is a quick attack like that, and also there is this sort of like heavy attack over here. Yeah. What I want to do is to use only one attack animation, because we don't need to set up entire combo to learn what we will learn in this video. But I just want to tell you that in the main part of the course, when we develop a state machine for the player, we're going to use all attack animations and we're going to have combos and so on. Okay, now let's go find the first animation. It is over here. The starting sprite is number 14. And we're going to select sprites until this one. We're going to drag them here. And let's change sample rate to 15. I think attack can be a bit quicker than other animations. Let's see it. Okay, it looks pretty good. I like it. But what I want to do is to add a couple of frames over here, so it looks like she put in weapon back. Okay, so what we can do here is to take this sprite, place it here, and this sprite, and maybe this sprite. Now let's see it. Maybe without the last one. Now it looks like she's drawing weapon back, and if we don't like it, we can always remove a couple of frames. Okay, now let's go ahead to Animator. And over here, we already have animation. It's time to set up transition to that animation. Let's go ahead and make a trigger. Sorry, maybe that was too quick. Plus trigger. And we're going to call it attack, like that. The transition to the attack will be from idle and move. And condition for that transition would be attack trigger. Let's uncheck exit time and transition duration. And let's set up transition back to idle move, but this time we're going to have exit time 1 and 0 transition duration. And we're not going to have any condition over here. In this way, animation will be played once fully, because we've set 1 on the exit time, and after that it's going to perform the transition. So they're going to be 0 transition duration, but transition will be done only after animation is played once. Now it feels like we're almost there, but actually we still have a couple of things to do. First of all, we need to go to the player and trigger attack animation. That can be done with the input from a mouse, and of course we need a function for that. I think I want to maybe move this over here. And below the handle input, I want to make private void, and we could call it attack, just like that. But actually, I want to call it attempt to attack, because you may not be able to attack all the time. Sometimes you may be busy, like jumping, and if that's the case, you will not attack. And it's going to be cleaner in the code. It's going to be more understandable if you write that you attempt to attack. Okay, so let's do if input get key down, key code, mouse 0, which is left click, then we're going to perform attempt to attack. And actually it is better to do same for jump as well. I'm going to press Ctrl RR, and this allows me to rename method across the project. So over here we're going to do attempt, or maybe, you know what, try to jump. Yeah, better. Try to attack. If this hotkey does not work for you, there should be rename, and it does the same, or you could rename it manually. Now inside of try to attack, we want to check if we are on the ground. If is grounded, because player should not be able to attack while it's jumping. Otherwise it will interrupt jump animation, it's gonna look buggy. So yeah, let's have if is grounded, then anim set trigger of attack, and make sure it is written the same way as you have it in the animator. I'm gonna go back to game window and scene view and go to play mode. Now I can walk, jump, and if I try to attack while I'm standing, I'm gonna perform an attack and then stop. If I try to attack while I'm jumping, it's not gonna work. The problem is now that you can see on the screen is I can move while I am attacking. And fix to that is actually not as simple as you might think. So what we need to do to fix it is to stop movement of the character while player is attacking. So how could we do that? Well, one of the solution is to sort of like register the moment when we started the attack and then register the moment when we finished the attack. And we're going to do that with the help of animation events. When game object has animator component on it, and if you attach another script to the same game object, you will be able to call functions from the script. Let's actually add component here, and we're going to do new script and give it the name of player animation events. Let's minimize it. So now animator game object has animator component and player animation events component. And now this animator will be able to call methods from player animation events script. Let's go ahead and try that. Let's delete start and update, and let's make a method private void attack started. Is it correct? Attack started? Can you say that? Should be attack begun, right? Anyway, let me keep it as attack started. And let's do debug log attack started. Okay, now I'm going to minimize the window, and here we need to choose animator, find attack animation, and then at any frame you can add event by clicking this button. Then you can choose a function from the script. Let's choose player animation event script, methods, attack started. Now, when you go to the play mode and try to attack, you're going to see message in the console, attack started. Let's clear it and do it again. Attack started, attack started. So as you can see, we can call a method from animation. Now, instead of a debug message, this method should stop movement of the player. And we can do that by calling a method from a player script inside of this function. And in that way, we're going to stop movement of the player. Basically, this is what it should do. Call method from player script. That method should stop movement of the object, player game object. This is what we need to do. So let's go ahead to the player script and make this functionality so we can call it from this function, from inside of this script, okay? Let's go to the player script, and what we want to do is to make private boolean can move, and it should be true by default. And we also want to have private boolean can jump, and it should be true by default, because you should be able to move and jump from the start of the game. Now let's go ahead and make use of these two booleans. Let's go to handle movement. And by the way, I want to show you a quick tip. Sometimes you have very big scripts. Sometimes you have lots of scripts over here, and it's not always easy to find the method you want. Just now I could scroll down. That was easy. Here is a handle movement. But what if I had like 20 or 50 scripts over here? Imagine going through all of them. So what you can do instead is find implementation of a method somewhere, just like I have over here. And then you can click right button and choose go to definition. And this will bring you to the place where this method was created. You can also go ahead and do this. Pick definition. This allows you to do some quick adjustment or look something and then go back to the place where you were. So over here inside of this method, we should type if can move, true. Then you can update velocity of the rigid body. Also, I should tell you that I'm writing can move equals to true like this because it's easier to read it that way, especially if you're a beginner. But I just want you to know that you can also write it this way, if can move. And this will do the same check. If can move is true, then do this. Also, you can write can move false, right? If it's equals to false, then do this. But an alternative to that, you can just go ahead and type an exclamation mark over here. And then it's going to be if not can move, which is if can move false, then do this. Yeah, that is a sort of like quick heads up. You're going to see it in the future again. So don't worry, you will learn how to use it with practice. Now let's type if can move just like so. And now you will not be able to move unless this boolean is true. Also, we need to modify the jump. The jump is over here, and we should be able to jump only if is grounded and can jump, just like that. Yeah. Now, you will not be able to move if this one is false, but if you're already moving, this will not stop the movement. I mean, you will not be able to do new input, but if you had movement before, you will keep your velocity. That's why we need to go to try to attack method, and if is grounded, we should trigger animation, and we should do RB linear velocity equals to new vector 2. Sorry, I got distracted. 0 RB linear velocity dot y. In this way, we're going to set velocity to 0, and character is going to stop when it's attacking. Okay? Very nice. Lastly, we need to be able to switch on and off these two booleans. Let's go ahead and make a public method. And we have a good reason to make it public, because we need to be able to call this method from outside of a player script. Let's do public void, enable jump and movement. And we need to pass bool enable over here, and this one can be either true or false. So it will depend on what value we pass into this function when we call it, true or false. We're gonna do can move equals to enable, can jump equals to enable. Now if you pass true over here, these two will be true. If you pass false over here, these two will be false. Now let's save it and let's go to player animation events. Over here, we need to call method from a player script. For that, we need to get component of a player. And to do that, over here, we're going to type private player. Let's name it as player. Then we're going to open awake, and we're going to do player equals to get component. And before we write anything else, I need to remind you something. Back in Unity over here, you can see that player animation events is sitting on a child game object, and player script is sitting on a parent game object. So if we try to get component from here, and this component is on the parent, then we should type get component in parent, like that. Let's delete this method and create a new one with a better name. Public void disable, how it was here, give me a second. It was enable jump and movement. Actually, I think it's better if we call it enable movement and jump. So let's do that. Movement and jump. Okay, because movement is primary focus. Now back over here, we're gonna do disable movement and jump. And this method will simply use player to call enable movement and jump, and we're gonna give it false. So we're gonna pass false over here, and I wanna remind you, because of that, these two will be false. Now let's make another method, and sorry, this can be private. Let's do private void enable movement and jump, and this one will do player enable movement and jump true. Now before we go ahead and test it, I want to show you something, well, quite important. When you have just one line of code inside of a function, you can write it like this, and it also will work. It's basically the same, you just writing it differently, but it does the same as this function over here. So if you have just one line of code, you can use lambda expression. This is what it is. And after that, you can write that exact one line of code. It's basically like saying, hey, this method, return me implementation of this method, something like that. It's not really useful right now, but when you have a very long page of a script, you can use this to reduce the, the the height of the script. I mean, to make it not so long, because when you have lots of functions like that, when you have like long script, then sometimes it is easier to type things this way to save some space. Okay, so just to develop a good habit, let's do it this way. Okay, very nice. So now we have disable movement and jump, which calls enable movement and jump false from the player, and enable movement and jump, which calls enable movement and jump true from the player. Now let's go back to Unity. Select Animator, Animation, choose Primary Attack over here, and you already have one event. You just need to change the method it has. Go to Function, Animation Events, Methods, choose Disable Movement and Jump. Then go to the last frame of the animation over here, add event, Player Animation, Methods, Enable Movement and Jump. And before we go ahead and test it, just make sure you have this line of code over here, to stop movement of the player when we perform the attack, because otherwise it's going to have velocity it had before. Okay. Now back in the play mode, first we want to check if we can move and attack at the same time. I'm going to attack and try to move to the right. Well, I can do these slides. I don't like it. Let me try to... Whoa, should not be there. What is that? I guess it's because of the sleepy material. If you do some changes in the play mode, they will not be saved when you exit the play mode. So let me delete the material and test this out. Yeah, it was because of the material. Okay, but we want to keep the material on. So this is what we want to do. Let's go to the player script. And I guess this one is not really useful, so I'm gonna remove it. Let's not clutter up the code. And we're gonna go to handle movement and type an else statement. Else, let's duplicate this line of code, move it here, and set x velocity to 0 over here, like that. Now, if you cannot move, you will have 0 velocity on the x and you will not move. Now, let's go ahead and double check that real quick. Okay, I'm running, I'm attacking, and I stopped. And I can do these small side steps, but it's fine. Other than that, we are not sliding around. We stop the movement of the player immediately when we do the attack. Let me try to attack and jump. Okay, perfect. Hello guys, welcome to the video. In this one, we're going to make logic for the attack so we can detect enemy and damage it. This will help us to learn 2 new techniques, which are very important for the main part of the course. So first of all, we need to make enemy. We're not going to animate enemy or anything like that. We did learn a bit about animations, and as of now we can just make some kind of a placeholder just to make the logic. The enemies itself are going to be a bit complicated, and in the main part of the course we're gonna do that. We're gonna learn how to make enemies, how to make them walk, attack, and how to stun them, and so on. As of now, let's do some simple kind of enemy. Okay, let's do 2D sprite square. Let's name it as enemy. And let's add component of a new script, enemy, like that. Let it compile for a second. Okay, now what I want to do is to just debug a message when enemy is detected and damaged. So let's go to the enemy script. And over here, we're just gonna make a public void take damage. And inside, let's do a debug log. Game object dot name plus, and we're going to do some sort of a message, took some damage. Yeah, this should do it. Now what we need is to make this enemy detectable, and then we need to detect this enemy when we doing the attack and call this function from the attack method. That's what we want to do. It may sound complicated if you are new to this, but bear with me, it is very achievable and we can do this within one video. So first of all, to make this enemy detectable, we need to give it a collider. Let's give it a collider 2D. Now it has a collider, and if it has a collider, same as a ground platform, it can be detected with a collision. And that's what we're going to do. But before we do that, let me explain something else. You already know that you can create a variable for something, but you might not know about arrays and lists. Array and list is very important in programming, and I will try to show you both of them real quick. So let's type over here public. Let's use collider this time. Let's do collider to D, and over here you can type square brackets like so. And then let's call it something like colliders. All right. So what you should know about this is that now, instead of having one variable over here, you have set of variables. Let's go back to Unity. And over here in Unity, you can see we have a variable that is named colliders. You can go ahead and give it a number over here. As example, let's use 3. Then when you expand it, you can see you have 3 elements under the same name. Basically, it's like having a set of boxes where each box holds a value of the same type, and each box has a number. If you would have to use first element in the list, you would refer to it with the index 0. You would simply go and do something like colliders 0 equals to get component and so on. Yeah, this is a quick example. And this is how you can collect multiple variables of the same type under one name. We're going to be using this from time to time, and it's quite important, but if you feel like it's confusing a bit, don't worry about it. With practice, it will be easier to understand. So, you know how to make set of variables under the same name. And this you can do with the array. You can also do this with a list. Let me quickly show you this. Public list of collider 2D. And let's name it as example list real quick. What did I do wrong? This should not be here. And you might have yours underlined as well. I guess to fix it, we need to press Alt-Enter and choose using system collection generics. Now it is fine. Okay, it's supposed to create this one automatically, but maybe it will not, so type it manually. Now, we did create a list, and if you go back to Unity, you're going to see another variable, and you can give it a number as well. And now this sort of the same as an array. It has 3 elements, and you can refer to them with the index you see over here. If you want to choose first one, you need index 0. If you want to choose second one, you need index 1. So they are very similar, but they do have a difference. Difference between array and list is quite simple. For the array, you can have only fixed size. You set size when you create array, and list can have dynamic size. You can increase the size of a list or reduce it on the go. Array is not as flexible as list. In the array, you cannot add or remove items when you already have filled array with something. You cannot add or remove items on the go. In the list, you can add or remove items on the go. And you might ask me then, why not use a list all the time? Well, it's not actually needed to use a list all the time. Sometimes it's cleaner and easier to use an array. And also, performance-wise, list is slower than array. Yeah, so this one faster and this one is slower, something like that. But honestly, in the context of this game, you will not notice the difference if you use one or another one. And also let me quickly give you an example of usage of these two. This one is better to use when you have fixed number of something, when you already know how many elements there will be, for example, skill slots of the player, right? You know you're gonna have only 4 slots for the skill, so it's better to use array. But for inventory, you don't know how many items player will carry, so it's better to use list so you can add and remove items on the go. Yeah, that's the idea. Now, I'm telling you about all this because we're going to use array to detect enemies in front of the player to hit them all together. Let's try to fill up this array with enemies we detect. We're gonna make another header. Let's do header attack details. In the attack details, we need to know private float attack radius. We also need to know attack point, from where we're doing the detection. If I comment this out and go back to Unity, I can show you this. We're gonna select Animator, Animation, Player Attack, and let's find the place where player is attacking. Let's go over here, find the frame of the attack, and we can see this is the area of a damage basically. So we need to do check in this area. And for that, we first of all need to know the point, the center point, so we can check colliders in the radius of that point. So that's why we need an attack point. Let's go back to player. And let's do private transform attack point. We also need to know what we're detecting. And we know we're going to be detecting enemies. Let's do layer mask, where we're going to define what is enemy. Okay, very nice. Now let's go ahead and make the logic. Somewhere here we can make a method, public void damage enemies. Inside of this method, we're going to take colliders we created. We can name it as enemy colliders, actually, enemy colliders. And we're going to make them equals to anything we detect in a certain area. Let's do this. Let's type physics 2D. And over here, we're going to use overlap circle all. This one will detect anything that is overlapped by the circle we set up. We need to know the point of the circle, so we're going to use attack point dot position. Then we're going to use attack radius, and we can add a layer mask to this one. What is enemy? Yeah, this is what we're going to have. This will detect enemies. Let's go ahead and check if this works first, and then we can go ahead with the development of the detection. I just want to show you how we're filling up array with the objects we're detecting. To call this method, we need animation event. So we're going to go ahead to player animation events over here. And we're going to make public void damage enemies. And this will do player damage enemies. Now save everything by pressing Ctrl+Shift+S and then go back to Unity. Over here, we can set enemy colliders to 0. Just do that, it's fine, because we're going to update the info when we detect the enemy. Then let's go ahead and create empty object. Oh wait, we did not make any gizmos, right? We will not be able to see the attack radius. Let's go back to the script, find on draw gizmos, and over here you can do gizmos, draw wire sphere from attack point dot position in attack radius. Like that. Save it, go back. Now let's create empty object and call it attack point. Then find a player and drag this transform over here. Then increase radius and you're going to see radius of the attack. I think I'm going to make it as 0.8 and I will place this attack point you selected and move it in front of the player like so. So now when you're performing an attack, you're detecting everything in front of the player. Maybe it can be moved a bit further. Let's take it and move it over here. Check again. Yeah, this looks good to me. I like it. Now we also need to give it animation event, but let's wait a little bit. Let's go to the player and see what else we need to assign. We need to assign what is enemy. Let's go to the layer, add layer, make new layer of enemy. Then select your enemy and give it layer enemy. Then go to player and choose what is enemy, enemy. Lastly, we need to select animator, find player attack, find the frame of the attack, which is here. Click add event and choose animation events, methods, damage enemies. Okay, we're good. We're almost there. This is an error message. You can ignore it. Let's go to play mode. You can see now it is empty. Then I'm going to go ahead closer to the cube and I'm going to try to attack it. And Boom, we can see we've added one collider to the array because we did detect it with a physics check with the help of this line of code over here. Right, what we're doing here is something extremely simple. You can see it returns a set of colliders, and we're doing check from the point we defined, which is the attack point, in a certain radius on a certain layer. If we detect anything, or whatever we detect, it can be nothing, we then turn it into an array by simply making array we have equals to the information we detect. This is how we're doing it. Yeah, if you go out of a play mode and add another enemy over here and try to attack again, you're gonna see you select the player, you have added 2 enemies to the collider array. Now, if you try to attack again, it's gonna change it, but it's gonna be same set of colliders. If you move one enemy away and try to attack again, you're gonna see it has only 1 collider in it. So this is how it works. Now that we know how it works, how it's detecting enemies, we can go ahead to the player script, delete this variable, then go over here and make it as local variable. So it's going to be used only inside of the function when we need it, and then it's going to be removed from the memory. Let's do collider to the array over here. So it's the same. Now, next step would be to do something with the enemy when we're detecting it. And what I want to do is to call damage method. There is such thing as a for loop and for each loop that allows you to work with a set of elements such as array or list. We're definitely going to be using all of them eventually, but as of now, let me just show you for each. You type for each like that, and you select the second one, or you can click tab twice. Now you have for each loop. It works in a simple way. First, you define what variable type we're working with. In this case, it's going to be collider2D. Then you give it a name so you can refer to it. Let's give it a name of enemy. And then you define in what collection you do this action. In our case, we're doing it in the set of arrays we detected. So we're going to do this in enemy colliders. And then inside, you're going to write what is going to happen for each element that we have in the collection. In this case, for each element, we're going to try to get component of the enemy. And then we're going to do take damage method. So as I said, it will do something for each element in the collection over here. And then we grab an element with the help of a name we created over here. Then we're trying to get component on that element and we're searching for enemy. And because we only detecting enemy layer, we're definitely going to be checking only enemies. So after we detect enemy component, we're going to call a method from that component, and it's going to be take damage. Let's save it. Let's go back to Unity. Let's hit play mode. And now I'm going to hit enemies. And you can see we have enemy 1 took some damage. Enemy took some damage. It's working. Congratulations. Yay. In this one, we're going to be discussing timers and cooldowns. It's very important to know how to work with timers. It's very important to know how to set something on cooldown, especially when you want to make an RPG game, because you will need to, let's say, set the skill on cooldown when it's used, or you will need to respawn an enemy after some time, and so on and so on. So it is quite important. In this video, I'll show you a couple of ways of making cooldown. We're gonna take a deep look at them so you understand how it works. But also I wanna say that I have a video that I've attached to this lecture that you can check out. And that video shows 5 ways of making cooldown in Unity. If you wish to extend your knowledge and learn more about this, I highly recommend to watch that video as well. It's not very long, just 5 minutes or something like that. But again, it's optional. That is if you want to. Now let's get to business. First of all, I want to remove one enemy because we only need one for this example. Let's move the script above, and then let's open the script. So as of now, when enemy takes damage, we just debug a message. I want to make something more noticeable. I want to turn enemy red when we damage it. So let's do this. Let's do private sprite renderer SR. Then in the wake, we're gonna do SR equals to get component of a sprite renderer. Then when we take damage, we're gonna do SR color equals to color.red. Now enemy will become red when we damage it, and we wish to make it white again after some time. There are a couple of ways to do that. The easiest one would be to use invoke. Invoke allows you to call method with a delay. As example, let's make a private void turn white or something like that. And then over here, we're gonna do SR color equals to color.white. Then when we take damage, we would do invoke. Then in quotation marks, we need to type name of a method, turn white. And then after some time, we can call the method. In this case, it's gonna be done after 1 second. Maybe actually let's make private float red color duration. So this will define how long enemy will stay red when we damage it, right? And we can use it over here and we can extend it if we want to. So this will work. Before we go ahead and test it though, I want to quickly show you something important before I forgot. There is a trick on how to make it less error prompt. Means if you use it, it will be harder for you to make a mistake. You see, the thing is you have to type name of a method with a string over here. If you mistype it, or if you change the name of a method to something else later on, it's not going to be changed over here. And it's not going to work. So instead, you can go ahead over here and turn method into a string. You're going to do this by typing name of, open parentheses, and you use the method. Now it will take the method and it will convert it to a string. And because of that, the invoke will work. Yeah. And now if you change the name, it will stay the same. I mean, it will be changed everywhere and it will not stop working. Okay. So whenever you want to use invoke, I suggest to use name of. Now let's save it. Let's go back to Unity. Let's go to play mode. I don't see the number 1. I don't see a red color duration. Wait, this should be serialized field. Okay. Again, let's go to Unity. Now we see it. Let's go to play mode. No, play mode. Now I have the enemy, I kick it, it becomes white after 1 second. If I extend the duration to 3 seconds, it's going to take 3 seconds to make it white again. Right, so it works. And it was quite easy, right? But the thing is, using invoke is not always the best idea. More to that, invoke is not really flexible. As example, if you try to pass some parameter over here into parentheses, you will not be able to invoke the method. Now let's talk about something else. What I want to discuss is time.delta_time. Let's remove this one from here. We don't need it anymore. And let's go ahead and open update method and type debug log time.delta_time. Now, if you hear about it for the first time, you should know that time.delta_time gives you interval in seconds that it took from the last frame to current one. Let's go and see what we have in the console, and then I'm gonna explain it more, okay? Let's save it. Let's go back to Unity. We go to play mode, and in the console, we can see extremely small value. So this one essentially shows you how long it took from one frame to another, from last frame to current one. And this value is always extremely small like that. Why do we need this value and how does it work? So because time.delta_time shows you time that has passed since the last frame, essentially it acts as a small consistent time unit that can ensure frame rate independency for whatever you want to do. You can do it for movement or you can do it for some calculations. The idea is simple. When your FPS is higher, the value is smaller. When your FPS is slower, the value is higher. So essentially this value adjusting itself to stay consistent, and we can use it to do some calculations. We can use it to make movement frame rate independent and smooth when you working not with velocity but with the transform position. And also we can use it to make timer in the game. Let's go ahead and make public float timer. Then int update, let's do timer. And over here, you can either increase or reduce the timer, depends on what you like more. I usually prefer to reduce the timer. So you can do timer equals to timer minus time.delta time. This is how you can write it. Also, you should know that there is a different way of writing the same thing. It's very common. You can type it this way. Timer minus equals time.delta time. As a beginner, it might feel a bit confusing, this type of writing, but it's better to get used to it because this is how people mostly prefer to write things. So let's develop a good habit from the start, and let's type it this way. Now let's go ahead and make another method while we are here, private void update timer. Over here, I'm gonna do timer equals to red color duration, and I'm gonna do context menu update timer, so we can call it from the inspector. This will be needed to explain how we're gonna use it. Let's save it. Let's go back to Unity. Now, over here we have timer, which is 0. Once we go to play mode, you're gonna see how it's gonna reduce itself and go to negative. You can see -2, -3, -4, essentially works like seconds, we just going backwards. Right? This was achieved with help of reducing value with time.delta time. And because it is frame rate independent, essentially it does count in the same way all the time. Now, when I go ahead and set this timer to the value I've set in the method, to red color duration, over here, when I do that, you're gonna see how value will become positive. Let's change it to 5. Gonna click right button, update timer. Now it was 5 and it's reducing itself. And then I'm gonna do this again when I want to. Update timer, it's 5 again. Goes to negative, now it's below 0. Then I can do it again. So the point is that we can do it not when we click the method in the inspector, but we can do it when we cast a skill or turn enemy red. And when timer goes below 0, we're gonna make enemy white again, or we will allow to use skill again. Essentially, that will be the cooldown value, because you set timer to 5, and during these 5 seconds you cannot do anything, but once timer is below 0 again, you can do something again. That's the idea of it, right? Again, once more, we have timer that always goes to negative, and then when we call the method, do damage, cast a skill, or respawn an enemy, we update the timer and we give it a cooldown value we want to have on it. In this case, it would be 5 seconds. We cast a skill. 5 seconds, we cannot cast a skill anymore. And then we say, well, if timer is below 0, you can cast skill again. That's the whole idea of a cooldown with time.delta time. Now let's go to enemy. And over here, I'm going to remove this. But I'll go to take damage and I'll say timer equals to red color duration. Now every time I damage enemy, the value will become positive, and we're gonna have it there positive until it goes below 0 by itself. And then in the update function, we're gonna do if timer is less than 0, then it means it's time to make enemy white again, because enemy was red for a certain duration of time that we have over here. So if timer is below 0 and SR color is not equals to white, then SR color equals to white, like that. Well, let's save this. Let's go back to Unity. I'm gonna set red color duration for 2 seconds. We're gonna go ahead and test it. Gonna damage enemy, it is red, and then it becomes white. So it works. And you can see when it's turning red, the value is bigger than 0. It is 2. You can see it over here, right? Then it goes to negative, and when it's below 0, it's white again. So this is how you can make cooldown. It can be the other way around if you like. You can do timer plus time.delta time. Then you check if timer is bigger than 0. And then when you remember the time itself, you're going to set timer to negative value. And it will do essentially the same thing, just in opposite way. You know, I learned that for some people it's easier that way. For some people it's easier that way. For me, it was easier with like when it goes to negative, but all the examples I've seen was using positive. So now it goes up. I'm gonna damage enemy, it goes minus, then it goes up again. Yeah. Now there is another example on how to make cooldown that I want to show you because we're gonna be using it in the main part of the course. For example, for combo attack of the player. Let's remove this. Let's remove this. And let's remove this. And let's make public float, public float, current time in game. We're going to be talking about time.time. If you know about it, it's going to be easier to do what we're trying to do here. So we're going to do current time in the game equals to time.time. Time.time shows you time in seconds that we have on the current frame since the start of the application. Basically, the timer is going to start since the moment you hit the play button. Let's go ahead and see it. Let's save this. I'm going to click play button. You can see current time in the game goes up. 1, 2, 3. This is essentially seconds that passed since the game began. How can we use it? Well, if we have time in the game, we can save up the time we had when we damaged enemy in a variable. Let's do public float. Last time was damaged. And then over here, we're going to do last time was damaged equals to time.time. Save it, go back to Unity again. Now in a play mode, we can see timer goes up. I'm going to damage enemy, boom. And we can see a damaged enemy when it was 3.4 in the game. How can we use it further? Well, we can go ahead and in the update, we can check if current time in the game is bigger than the time we had when we damaged enemy last time. And we're going to do plus red color duration. This is what we're going to be doing. So essentially, this serves as a cooldown for something, and we're going to use it in combination with the last time was damaged to make a cooldown value. How does it work? Well, let's, you know what? Let's just go ahead over here and do this. If SR color not equals to white, then SR color equals to white, like that. The logic is done. It's going to work, but let's go ahead and see how it works. Duration is 2 seconds. I'm going to damage enemy. It is red. And then it is white again. Now let's discuss how it's working. I'm going to hit the enemy and I'm going to pause the game immediately. Boom. Almost immediately. So you can see the current time in the game at the moment is 11.4. The last time I damaged enemy is 11.4. And red color duration is 2 seconds. So since the time I damaged enemy, it should stay red for 2 seconds. And then it should become white after 2 seconds has passed. Essentially, it should become white at 13.4. And that's what is happening here. When the time in the game reaches that value, when this value is bigger than combination of these two values, it becomes white again. And you can see it here. The timer goes up, 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 up. And it will take some time, but I'll get there. We're gonna keep frame by frame. You can see time in the game is increases and it's 12.4 now. So let's go there. We can see time is passing in the game. And then, hope it is white. Because at this point in time, this condition was met, it became true, and we turned enemy white, if it was not white. Yeah, so this is another way of making timers and cooldowns in Unity. They're all efficient, they all can be used, but but sometimes it's better to use one, sometimes it's better to use another one. Depends on the situation. We're gonna have more practice with it, no worries about that. Okay, there are a couple of other ways to do it, but I think it's not time to learn that. As of now, this is good enough. We can turn this into a method, extract method, change color if needed, and that's it. Alrighty. Thank you so much for paying attention. Check out the video that attached to this lecture if you want to learn more ways of doing cooldown, and I'll see you in the next one. In this one, we're going to be discussing object-oriented programming. If that sounds scary, don't worry about it. These principles are quite simple. It's sort of like easy to learn but hard to master kind of thing. We're going to be discussing inheritance, polymorphism, and encapsulation. And basically, it's three main principles of object-oriented programming. Three pillars that hold in it, basically. I want to start with inheritance because it's very important and it's best to start with this one. Let me briefly explain what is inheritance and then I'm going to give you a practical example. So inheritance, let me open enemy script, allows one class to inherit properties and functionalities from another class. Essentially, you can make parent-child relationship, and parent, the base class, can have some general functionality in it. And also you can make a child class, and that child class would inherit from parent class. And this would allow child class to use general information on the base class inside of a child class. And also you could add new functionality to the child class without affecting parent class. That's the idea of it. Now let me give you some practical example. And honestly, I would do it inside of enemy script, but I don't want to delete all of this. Someone might want to take a look at the script in the end of the section. So let's rename this one. We're gonna press Ctrl+RR and type cooldown example, like that. And make sure you have checked rename symbols file, and then press enter. Now it's gonna be different file with different name, but script will be the same. Or you can just change the name here manually and then go to Unity and change name here for the file as well manually, and it's gonna be fine. Now let's go back to Unity. Let's remove component over here. And let's make new component. This one we're gonna call enemy. Let's open enemy and let's close other tabs. Now let's think what general functionality each enemy should have. Each enemy, I suppose, is able to walk. So we need public float, move speed, right? And then each enemy, I suppose, should have a name. So let's do public string, enemy name. There could be much more to this. That could be health, damage, armor, and so on and so on and so on. But we need only a couple of variables for this example. So let's stick to the move speed and enemy name. Now let's say each enemy should be able to walk. So we should make a general method that enemy will use. Private void move around. And inside let's do debug log enemy name plus moves at speed plus move speed, like that. And each enemy should be able to attack. So let's do private void attack. Inside we're going to do debug log enemy name plus attacks. Just that. And I just want to remind you that I'm giving you simple examples with debug lines so we can focus on the inheritance itself. But usually it's much more complicated than that. Usually you have to set animations, cooldowns, skills, different behaviors, multiple behaviors. But we can do it with the debug line. Then let's open update. And in the update, we should say that enemy is always moving around. And if we do input get key down, key called F, enemy attacks. Like that. Okay. Now let's go back to Unity. On the enemy over here, I'm going to add enemy script. It will have move speed 1.5 and enemy name will be skeleton. Let's click play button. And we have enemy walking around. Oh. I did break something. Let me check. All right. So we're detecting the enemy over here with the attack, just like we did before, because of the layer, but this enemy does not have cooldown example component on it, and we see error messages that says null reference exception, means it does not have a component you're looking for. To fix it, let's just let's change this for enemy, just like it was before over here. And on the enemy script, let's make public void take damage. Okay, this should fix the error. Yeah, okay, good. Back to the business again. I go to play mode, and I'm gonna press F, and we have skeleton attacks. Perfect. Now let's say you are ready with a skeleton and you want to make a new enemy. You want to make enemy goblin. An enemy goblin should have functionality of the enemy, but it also has some specific functionality. For that, you would go ahead and make new script, enemy goblin. You open the script and you know that enemy goblin should have move speed, and it should have the name, enemy name, and it should have everything you have over here. And you could just go ahead and copy this and paste it in here, but that would be extremely wrong to do because this makes your code a mess. We just copied 4 methods and it seems okay, not like a big deal, right? But imagine you have a script like this on the enemy. You have this much of a functionality. Copying all of that to each enemy feels really redundant because you would have to not only copy this, but you would have to add additional functionality for each enemy. Imagine how big of a mess that would make. So instead, you go ahead and you inherit from the enemy over here, like that. Now, enemy goblin inherits from the enemy, and it has all functionality that enemy has over here, and enemy inherits from mono behavior, essentially making so enemy goblin inheriting from the enemy and enemy inheriting from mono behavior means enemy goblin will have access to the enemy and to mono behavior as well. That's why you don't need to go ahead and type something like mono behavior over here. It's all shared, right? Now you can see this script is completely empty, but if you go to Unity and you make a new enemy, let's duplicate this and make it like that, name it enemy goblin, and then we would remove enemy script and add enemy goblin script. And you can see it has move speed and enemy name, even though the script itself is empty. It is because we inherited from enemy, and enemy has all those properties. Now you could use it, even methods. You could go ahead, give it move speed of 4, and say that this is a goblin. And if you go to play mode and press F on your keyboard, first of all, you can see both of them are walking, so functionality is shared. And also if you press F, you can see goblin attacks, skeleton attacks. So they do share functionality, even though there is nothing inside of this class, because we're inheriting from enemy. All right. You might ask me, why would you make new enemy goblin script if you have functionality on the enemy? Just add the script to the object and give it different name in the inspector, and that's it. You would be right if we would not have to, or if we would not want to add extra functionality to the goblin. Let's say I want goblin to be able to steal money from the player, but I don't want base enemy to be able to do that. I don't want skeleton to be able to steal money from the player, only goblin. In that case, we have to make a new script, use the functionality from the enemy in it, and also add another method. Let's do private void steal money. Now this would have a new functionality inside of it without affecting whatever we have on the enemy script. And also because this one has public variables in it, we can use those variables on enemy goblin. We can go ahead and do this. Debug log, and pay attention here. There is no variable declared over here, but I can still use it in the method enemy name because it is created on the enemy again, right? That's why we can use it here because we inherit it from the enemy. And we do enemy name plus steals gold from player. I forgot plus sign. Like that. Oh, sorry. And let's use context menu for a second. Steal gold. Save it. Go back to Unity. Now we go to play mode. We can see that we both can attack. I mean, both enemy can attack when you press F, but enemy does not have steal gold in it. Only enemy goblin can steal gold, and that is his special ability. Goblin steals gold from player. So this is how you use inheritance. You share common functionality on a base class and additional special functionality you add on a child class. Let me quickly give you an example on how it can be useful in a project that is in a sort of like bigger state. And I know there is a lots of things in this project. Don't pay attention to them, just focus on this. I have a player over here, I have a skeleton, and I have an archer. And you can see all of them have a health bar above. They all should have an animator to play animations. They all can walk, they all can attack, they all can do something similar. And for that, I have created a base class of entity. Like for example, let me go to that class over here. So you can see each entity has a components that we're going to use. Each entity has a flip functionality that we created with you before, right? And each enemy has a collision detection and so on. So in that case, it can be written in a base class. So we inherit from the base class over here, because this one has a common functionality, such as getting components, flipping the character, checking the ground, and so on. But when it comes to specific functionality, I go inside of this class and write functionality there. When I have specific functionality for Archer and I don't want it to affect Skeleton and a player, I write functionality inside of the Archer. For example, Archer can bounce back when player getting close to him, but Skeleton should not be able to do that. So in that case, I write functionality on a child class, but general functionality is done on a parent class. Yeah, that is a simple example of inheritance. And if it sounds a bit confusing, don't worry about it. We're going to practice with it, for sure. Something else you should know about inheritance. Let me close the player. We did create public variables, and they are available on enemy goblin. If you open a wake method, you can change move speed to a new value. But if you make a variable private, like so, and I'm saying this because you should make variables private most of the time. If you go to enemy goblin, you can see it is not available over here. It says inaccessible due to its protection level. So that's the problem as well. So to make it shareable between parents and children classes, but keep it private at the same time, you should make it as protected, like so. Now it is private unless child class trying to get access to it. And you can see it is available. Give it a second. It is available on enemy goblin. And you can and should do this for methods as well if you plan to change those methods. And here, by the way, when it's protected, it's hidden in the inspector, so you should make it a serialized field. Serialized field, protected. Yeah, so I was saying that you should do same for methods if you want to change them or adapt them on a child script. And here we slowly come to next principle of object-oriented programming. I'm talking about polymorphism. Hello guys, in this video we're going to be discussing one more principle of object-oriented programming. It is called polymorphism, and before we go ahead and take a look at the example in the script, I want to try to briefly explain what is it so you have better understanding on what we're trying to do. So polymorphism allows you to change functionality for the same command or method. Two different objects can use same method, but what is inside of that method can be different. For better understanding of what I mean, I'm going to give you a perfect life example. Imagine there is you and there is me standing in the room. And then someone comes in and tells us to dance. You would dance in your own way, and I would dance in my own way. We both dancing, but we do it in a unique way. We both performing the same function, but what is inside of this function is different. And in the same way it works in the script. You can have same function for two different objects, but you can adjust them and make them do their own thing, and that essentially would be the polymorphism. So the polymorphism is basically one command, different behaviors. This is what it is. Now let's take a look at a quick example. What if we want Goblin to be able to steal money when Goblin attacks? What we would do then? I'm assuming the first thought that comes to my head is to make a new method. Private void special attack. In here you would do steal money, and then you would do attack method, which is not accessible because it's private. So you go to enemy, you find private void attack, you make it protected void attack. Now it is accessible on a child script, and you can go ahead and do attack here. Let me move context menu over here so we can call it. And I'm gonna save this. Sorry, this should be special attack, right? I'm gonna save this. And when I go to play mode, I'm gonna press F key, Goblin attacks, skeleton attacks, nothing was changed, all the same. But if I go to enemy Goblin and call that method special attack, you can see Goblin steals gold from player and Goblin attacks, all done at the same time. It is the way to do it, but there is actually easier and better way for that. You can override the method and change its functionality on a child class. To make it possible to override, first of all, you go ahead and make it as virtual void, like that. This will make it available for overriding, yeah. And then on enemy Goblin, you go here and you simply type override and you choose what you want to override. In our case, we want to override attack. Now, whenever you call attack method on enemy Goblin script, even if it's done in the base class of the update over here, whenever attack method will be called on this class, it will call the method, then it will call the base class, which contains a simple message enemy attacks. And then after the base class was called, it's going to do something else here, whatever you add. And as example, we can add simply steal money here. And now, instead of creating a new method for whatever we want to do, we can simply override the attack method and give it additional functionality such as steal money. Now, when you save it, whenever you call attack method, either it be with a cooldown, detection, or input on a keyboard, enemy Goblin will perform base attack that we have over here, and also it will perform next line of code, which is stealing money. Let's go ahead and see this. Here in Unity, I'm gonna press F, and you can see Goblin attacks, Goblin steals gold from the player, and then skeleton attacks. So this two was called together, and this is the example of polymorphism. As you can see, two different objects using same function, but each object performing their own version of that function. It can be done for multiple things. Over here we did add the special functionality to enemy Goblin, but you also might have enemy that instead of dying creates two new smaller enemies. In that case, you would override die method, and on a base class enemy would die and just drop some items, but on a child class it would die and spawn two new enemies, right? So these are two simple examples of what you can do with inheritance and polymorphism. There is another quick example that I can suggest. It's also useful, by the way. Let's say we want to make a new enemy archer. Let's go back. I'm going to exit play mode. Let's make enemy archer. Now let's go to enemy archer script and We know that enemy archer should be able to walk, should have health, and so on, and we don't want to remake it manually, as I mentioned before. That would be silly. It's not only like an extra job of copying code, but also imagine you have hundreds of enemies. It would be extremely tedious to do as well. So you just inherit from the enemy. Now archer has functionality of the enemy, not enemy goblin, only enemy, because we're inheriting from the enemy. And we don't have any special attack for the archer. It does not steal gold, it does not burn player, nothing like that. But it has different attack. Instead of hitting the player, it's shooting an arrow. And you might have functionality on the enemy already that does attack with a cooldown and detection, all sorts of stuff that are important. You only need to change the attack's behavior itself. So what you do instead is you go to enemy archer and you override attack. And this time, instead of adding extra functionality, you remove the base class. Now it is empty, it is nothing there, and it will only perform things you say. As example, you say debug log enemy name plus shoots an arrow, like that. And this is also example of polymorphism. You change the functionality of the base method in some way. So that is polymorphism as well. Let's go back. I'm going to make triangle enemy archer, and I'm going to give it the script of enemy archer. And this one, let's say, runs faster, and it has name archer. Now, when you go to play mode, and I cannot jump over it, it's okay. You press F key, you see that archer shoots an arrow, and these two same as before. So it does completely new functionality that you write in the method. It does not say archer attacks, it says archer shoots an arrow. But in actual project, not in the example, you would actually make it to shoot an arrow instead of doing simple attack, right? That's what you could do. Yeah, I really hope it all makes sense to you. If it does not, just give it some time. We're going to practice with it. We're going to have more examples, and it will be easier to learn and understand. In this one, we're going to be discussing last pillar of object-oriented programming, that is encapsulation. We're going to work with it more. I'm going to show you how to use it in the main part of the course. But as of now, let me just give you a quick and simple example so we can briefly talk about it. You might need a variable on another script just sometime, for any reason. You want to see how much health enemy has before you damage it, or you want to calculate damage according to enemy's evasion, or whatever comes to your mind, right? You might need information from the script on another script. Say we have a move speed and enemy name on the enemy, right? I'm going to put this above. And it is protected, so it is accessible only inside of enemy script and scripts that inherits from the enemy, such as enemy goblin and enemy archer. But what if on player script, when I try to damage the enemy, after that I want to debug a message that I damaged or I killed this enemy? For any reason. It could be different functionality, but essentially what we're trying to do here is to get a variable from enemy script to do something. So for that, I would have to try to get access to that variable from the enemy. So I would, we're gonna clean this up a little bit, but as example, I would do enemy get component enemy, and over here I would try to use enemy name. But it is not accessible due its protection level because it is protected. It is only available to enemy and children script. But we need this variable. We really need it. What we could do? Theoretically, we could make it public, right? If you make it public, it would be available over here, and you could do something with it. Whatever you want. You could do debug log of the enemy name as example. But it is honestly the bad practice to do it, because if you make each and every variable public, it could make such mess in your project you cannot imagine, especially when something is not working and you're trying to debug it and you don't see where those variables are modified, what functionality is included, and so on. So this one, encapsulation, should be used so you make your code safer and easier to manage and use. One of the ways to encapsulate information, essentially to protect it, is to keep it private or protect it, and then to make a public method and return that variable with the help of a method. So you could have it as serialized field, protect it, and it will stay safe. And if you need that variable, you can make a method of a return type of a type of a variable you have. In this example, it would be public string, and you would name it as something like get enemy name. And this would simply return enemy name, just like that. And now we have encapsulated the variable into a method. And if some script or some functionality needs enemy name for some reason, instead of accessing variable directly, it can use method over here. Let's go to player. And actually, this is also a bad way of writing it. So let's rewrite this slightly. We're going to make a local variable of an enemy. It's going to be enemy script equals to enemy get component of enemy, like that. And now we can refer to component with help of this variable. And we would do enemy script take damage, same as before. And then we want to say something like I did damage this enemy. We would do, let's do string. We would do something like debug log. I damaged enemy. And over here we do plus enemy script get enemy name. And this would essentially return us enemy name, which is a text. If this feels a bit confusing, instead you can make a local variable for this as well. You would do string enemy name equals to enemy script get enemy name, and then you would use it here. Yeah, this is the example of encapsulation. Let's save this, and let's see what happens when we try to damage enemy. I actually want to remove the move functionality because it makes mess in the console. So let me comment this out. Go back. Now inside of Unity, let's select enemy archer and give it a collider, because otherwise it will not be damaged. I'm gonna give it box collider. It's fine. And actually now we cannot walk through enemies. So for a second, let's go and make them as isTrigger. Okay. And don't worry, we're going to discuss what is isTrigger later on. As of now, just make it true. Let's go. Now you can see I did damage enemy skeleton. If I go to the left and try to kick this one, I damaged enemy goblin. And this one will be... Wait, did I forget something else? Yes, I did forget to give it layer of the enemy. Okay, and I damaged enemy archer. So essentially, we got information about the enemy outside of the enemy, and we kept variable protected, so it's not available for anyone, but we did expose the variable through the method, and that is encapsulation as it is. Yeah. And more to that, now if you have a bug in the game and you're trying to see what is the problem, you can actually see where we changed the variable. Let's say you have a bug with enemy name. You can see where it is affected. Aha, it's in this method. So maybe something is wrong here. It's not how you usually do things. I never go and say, aha, this is the problem. But let's assume we do that. Yeah. Another way to encapsulate a variable is this. Let me comment this out for a second. I usually prefer to use this way, but sometimes it's easier to make variable public and then set it as get private set. What it does is it's making variable public to get, so any script can read this information. It can see the information, but only this script can change the information. So it's like saying it is read only for outside scripts, but you can change and edit inside of the script. And now if you go back to player, you can do this. You can do enemy script, enemy name, and you can read this information. But if you try to change it, equals to new name, you can see it gives you a message that says Come on. It says it cannot be used because it is inaccessible, right? That's the idea. Yeah, we do use it sometimes. It's honestly, I think it's up to the personal preference and your overall idea of how your project will be structured. I think both ways are valid. It just depends on what you're trying to make. Now I want to revert it back to what we had with a public method. And over here it should be get enemy name. And this would be it for now. We did discuss three major topics of object-oriented programming that are very important: inheritance, polymorphism, and encapsulation. Hey guys, as you might realized by now, these videos you are watching are part of the bigger course I have. This is not a promotion, by the way. I just want to give you my point of view so we are on the same page. So my original plan was just to take this video you watched and upload them to YouTube as it is. Just pack them together and post them because I have the videos done, so why not get some views and maybe more audience, you know? But then while I was editing the video and assembling them together, I realized that it may feel incomplete and maybe even unfair because we do learn a lot about movement, colliders and other stuff, OOP and so on. But as a result, you have just a character walking on the platform. So it may feel like unfair. To some people, it may even feel like a scam, right? So what I decided to do is to show you how to complete the project. I want to show you how to make enemies, and then we will make a level and enemies will walk into the level and try to attack a little girl in the center of the level, and you will have to protect the girl. We're gonna make some UI elements, and we're gonna do game over screen and some other stuff. And then if you want to, you can take this mini game and show it to your friends, family, maybe use it as a school project, or just, you know, just be super proud of it. And that's it. And now comes the promotion. If you do like my style of teaching, maybe just leave the project here and get the RPG course I posted in the description below, because this is the end of the crash course as it should be. And then we start making like a full scale RPG with complex systems, inventories, items, and so on. So if you do like how I do things, and if you want to learn like more, then check out the link. It's a very good course with tens of thousands of students, thousands of 5-star reviews. It's very cool. Yeah, I teach a lot there about game development. Okay, yeah, I get nervous because I always feel shy to do promotion. Anyway, let's continue. So we talked about inheritance a little bit, and polymorphism and encapsulation, which is all very useful, especially with what we're going to do now. I guess I'm going to give you a more practical example that will be really helpful. Look, we're going to delete these for now. We don't need them. And I'm going to delete these two scripts. Okay. Let's delete cooldown example as well. We don't need it at the moment. Yeah, I'm butchering everything now. The deal is I recorded the crash course maybe 5 months ago, and now I came back to it, and I just need to start from this point. Okay. So let's take input system and drag it into settings to make it a bit cleaner. And then let's make a folder for scripts. Actually, we're only going to have a couple of scripts, so we don't really need a folder. Let's go to the enemy script. And over here, we're going to remove everything. Don't worry about it. We just used it as example. Now we don't need it, so let's take it away. Okay. Now on the player script, you will have a couple of errors in damage enemies because we no longer have get enemy name function and take damage function on the enemy. But it is not a problem. As I told you, by using inheritance, you can reuse the code for multiple objects. What I want to do is to make an enemy, and to make it in a correct way and also to save us some time, we're going to reuse code we have on the player on the enemy, right? So we're gonna have functionality that we created here working on the enemy as well. For that, first of all, we want to somehow generalize this script, because now it is about the player and it is okay, but it may be a bit confusing if we inherit from the player over here, right? It's supposed to be like general info there. So let's do this. Let's go to the player and press Ctrl RR and rename it to entity. This is a common practice. Make sure you check this rename symbols file. And if you're using VS Code, then make sure you change name of the file as well. You'll have to do it here on the left. Okay, now if you go to the enemy, you can inherit from entity. Like that. Let's save this for a second and let's go back to Unity. You will see if I create, what's that? Oh, the errors, yeah, errors over here. Okay, for the time being, let's just comment this. I'm gonna press Ctrl KC. Okay, good. Let's close this up. And as a quick example, I'm gonna show you what's going to happen if we make an enemy object and attach enemy script to it. And as you can see, it has attack radius, attack point, what is enemy, move speed, jump force, and collision detection details, which we can use for enemies as well. It's going to be really easy to implement, honestly. But before we do that, we need to prepare everything. Sorry, I need to relax a little bit. I got too excited. How we preparing everything? When you want something to be used on child script, you need to make it either public or protected. Public will make it public overall, and protected will make it possible to use only on child scripts that are inheriting from parent script. We probably want to use Animator on the enemy, and we probably want to use a rigid body. So we're going to make them protected. Now, if you ever decide to go to enemy and do something with it, you will have access to rigid body. Let's do this. Start, and you can have RB linear velocity, right? If you would not make it protected, it would not be possible. Let me quickly show it to you. You don't have to type it now, just take a look. If I go ahead and make it private and save it, then on the enemy, when I try to type RB, it doesn't know what I want. It doesn't know what I'm talking about. It will tell you it's inaccessible due its protection level. That's the point. That's why we're making everything protected. Now, I already know what we're going to use as a protected because I just tested this and I made a simple prototype. And you will have to just trust my experience on this. But I will explain everything along the way, no worries. So we make rigid body protected. Then we go to attack details. Enemy will need attack radius to detect the player. So we're going to do protected. And I want to remind you, this will be used both by player and the enemy. I know if you're a beginner, it can be quite confusing, like how do we use the same code on two objects? But it's just something you have to make peace with, okay? You just have to understand it and accept it. Yes. Let's make these protected because enemy will need it to detect the player. What we're going to do is we're going to make enemy walk, and once player is in the attack radius of the enemy, so basically in this radius, we're going to make it attack. That's how it's going to work. So enemy will want to use protected move speed, and enemy will not be using jump force. So usually what you would do is you would make a new player script and you would take player related stuff to the player script. So enemy does not have it, like for no reason. But in this case, as of now, it's not really important. So we're gonna just ignore variables that enemy is not going to use, like jump force and X input. Although enemy will have to use can move boolean. So, but actually maybe not yet. So let's leave it for now. Okay, let's not do anything. We're gonna need to override update. So let's go over here and make it protected. And to make it possible to override, we're gonna do virtual. All right, very good. Now let's see what we can do with damage enemies. So this one will now basically damage target, not the enemy, right? We have to make it clear. So let's do damage target. Targets. right? And layer should be what is target, not what is enemy. So on the enemy script and on the player script, it is clear that we just selecting what is the target for this entity. Let's do what is target. Okay. Because we changed name, we will have to reassign it in the Unity, but it's not a big deal. Then over here, let's uncomment everything. Let's delete these two lines. We don't need them anymore. And over here, we're going to search for entity instead of enemy. So enemy will search for player's entity and player will search for enemy entity. But because we're going to select certain layers on a layer mask, it's going to find the correct target. Go here. And now entity, let's do entity target. Now entity is supposed to have take damage function, so we can actually damage the target, and then we don't have it yet. What you can do is click right button, quick actions, generate method. Now we have damage function. We're gonna write logic in there later on. As of now, it's not important. Let me see what else. We want to change how update works on the enemy because enemy does not need to check for input. And that's why I want to make functions that we will put into update as protected so we can actually use them. That's why we have to go to handle animation and make protected over here. I know it may not make much sense right now. Just give it a minute, you will see why we're doing it, okay? Now, when player tries to attack, we check if player is grounded, which is fine. But enemy is going to work in a different way. It's going to attack if target is detected. So we're going to go ahead and do protected virtual over here so we can override it and change it. And that will be example of polymorphism. You'll see it. Now, try to jump is not important, and this is what you would normally move to the player script, right? Maybe I'll show you that as well. Let's see. Like maybe we can do a bit of a cleanup after that. Then let's go to handle movement and make protected virtual handle movement. So player is moving according to X input. Enemy will move according to the facing direction. We're going to set default facing direction for the enemy to let it know where it's supposed to look and walk by default. Okay. That's why we need virtual, so we can override it and change it. Now we need to override handle collision. So we're going to do protected virtual void because we want to override it for the enemy so it can detect the player. We're going to need to add one line of code here. And I think for now this is it. There are a couple of more changes, but we're going to do them later. As of now, as a next step, we either have to go to the enemy and write the script or get animations. And I think we should get animations so you can understand what we're trying to do. On my Figma board, I've collected all assets I'm usually using for RPG project. And over here, you can find the skeleton sprite pack. If you don't want to get it here, you can go to itch.io, browse assets, free, and you scroll down here and find the skeleton. It's supposed to be somewhere here. Now I don't want to give up. It's somewhere there, honestly. But if not, just get it here. And then you notice how subtle my promotion was? Yeah, very cool. I forgot to download skeleton. Okay, we need to get skeleton. We just do download now. No thanks, take me to download, download, and it will give you archive. You just click open. Now I have it here. And we're not gonna use all of the animations here because we want to keep it simple and with the scope we have set, right? So what we need here is skeleton idle, just in case. We need skeleton walk and we need skeleton attack. As for dead and hit and react, if you want to, you can set them later once we're done with setting up the enemy's walk and attack behavior. Okay, very cool. Let's move them here. Let's select them, do compression none, no filter, 32, apply. Now, as a next step, maybe let's make a folder for all of it. Well, actually, let's set them up and then we're gonna move them to a folder. We'll make it easier. How are we gonna set them up? First, we need to cut these sprites. Let's open sprite editor, have it here, and this one is almost cut as we need. We go to slice, grid by cell size, 22 by 32, hit slice. No, this is wrong. Let me double check, okay? Because I just did it, but I forgot the numbers. It was 24 by 32. Okay, so 24 by 32, slice, apply. Very cool. Very, very cool. Let's take one of the sprites and attach them to the enemy. When we, where is it? Here it is. When we want to attach visuals to the object, we can either just take the sprite and drag it here, or we can add sprite renderer and assign image over here. Depends on what you like more. Let's take the skeleton idle and make it child of enemy object. Reset position, and let's move it closer to the player. Okay, it's obviously too small, so let's go to this object, change name to Animator, click this icon and increase scale. Something like 2, maybe more, 2.4. 2.4 seems okay. When you move the object, make sure you don't move Animator. Animator should be 0, 0, 0. Take enemy skeleton over here and move this one. And actually, maybe we should move visuals to the right slightly. Our goal is to have center of the object in the center of the visuals somewhere here. So let's take Animator and just slightly move it up and right and see it. Yeah, this looks good. I like it. All right, so these are my numbers over here. Basically 0.3, 0.3 on the X and Y. Cool, very, very cool. Now, let's go ahead and add Animator object. And we need Animator controller. So let's go to animations. Maybe let's make folder for controllers. Take player controller, drag it here. And let's make folder for animations. Take this, drag it to animations, make folder for player. Take animations, drag them to player. Okay, much better. Now, in the animations, we need folder for skeleton, but that will come a bit later. In the controllers, we need new controller, enemy. Okay, assign it over here. And then let's go to animation, create new clip, assets, animations, here in the animations, a bit confusing, we should change name of this one. Let's make a new folder, enemy. We select it and we type enemy idle. Save it. Then you go to graphics. We don't have graphics folder, it's okay. You go to idle, take these sprites, drag them here. Sample rate should be somewhat like 12. And let's see it. Yeah, it's okay, I like it. Very cool. Cool. Now we need one more animation. It will be enemy move. And let's go cut sprite sheet for walk animation. We go to sprite editor. And over here, I know the values as well, but there is an exception. We need to go to offset on the Y and type 2. So all the sprite cuts will move a little bit lower, like they will go a bit down into this direction. So offset 2, 32, 24. Oh, it goes to 1 automatically. Okay, let me see. This is not what we need. Let's make 22. Yeah, this looks about right. So I had offset 2 in my prototype, but I think it doesn't really matter. Let's try this one. We hit apply. Okay, let's close this. Let's take sprites. And now our goal is just to make skeleton walk. That's it. Okay, so let's do sample rate 12. Let's see it. Looks okay to me. Yeah. It feels like it does a bit of a jitter forward when it starts walking, but I don't think it's that big of a deal. Now, what I want to do is to make a blend tree. Did we discuss blend tree for the player? We did. Perfect. So we need to make something similar for the enemy. It will make our life so much easier. Let's take this name over here, x velocity, and go to the enemy. Make new float parameter, x velocity. Delete these two. Make new blend tree. Name it as idle move. Let's open it. And over here we add 3 new motions. Uncheck automate threshold. This should be enemy move. This should be enemy move. In between should be enemy idle. We go -1, 0, 1. Now you can test it by dragging this slider. Walks, stops, walks, stops. Cool, huh? Very cool. Love it. Let's go back. This will be default. Now, what do we need to make enemy walk? We need to tell what is ground. We need to tell what is target. Target is for the attacking, so let's leave it for now. But we do need to assign attack point, because otherwise we're going to have this error message. Let's make empty object, attack point. Assign it over here. Okay. Move speed may be too high. Let's try 2. Jump force is not important. It's not going to be used. Ground check distance. Let's make it 1.2. Although in this mini game we're going to make, ground check is not really important for the enemy. Right? Because it's going to just drop down and walk into the player. It's not going to see gaps or platforms or anything. This project is quite simple. Okay, now let's go to enemy script and make it move. As I mentioned before, we want to override handle movement function. This is what we do. And if you take a look at the base, it will have the code we have on the parent script, on the entity. This one works with the help of X input. We want to make it with a different parameter that is only used by the enemy. It can be used for the player as well, so let's just make it on a parent class over here. We're gonna go ahead and make protected int facing direction equals to 1. So if you're facing right, your facing direction equals to 1. If you're facing left, your facing direction is equals to -1. And we can use this to make enemy walk. For example, over here, we're gonna take the base. Do we need to cut it out, or we can be smarter about it? We can be smart about it. So, okay, look at this. We have 2 options. We can just take the code from here, go here, paste it in, and use this facing direction over here. By the way, can move should be protected, otherwise you can see we cannot use it. So let's do that. Let's do can move protected. Maybe like that, right? So you have can move. And over here, now it's working. And we could just leave it at that. Actually, perfectly fine to do that. I just want to show you one option you could do real quick. On the entity over here, you can introduce a parameter into function. Over here, you can do like float x direction as example, and use x direction over here. X direction for the move speed. Now, when you use this function, you can dictate what will be used as an X direction. And for the player over here in the update, you could type X input. And then for the enemy, when you use that, let's do override update, you could just ignore this function and go ahead and do handle movement with facing direction. And it would work perfectly fine. This shows you that there are multiple ways of doing same thing, and it's like mostly never right or wrong. It's just matter of personal preference. As of now, I'm assuming that it may be a little bit confusing passing parameters into the function, so let's keep it simple. Let's override the function and change the way it works, okay? So I'm gonna remove this for now, go back to the entity, remove this, and remove this over here, and use X input over here. For now, this should do it. Okay, back to the enemy. Now we have handle movement function that can be used. What we need next is override update, and we don't want to use base update we have because it's using input. We don't need it. We could leave it as it is. Anyway, enemy is not using input, but let's try to keep it clean. So this is what we're gonna do. We're gonna remove the base and we're gonna use these functions here again, right? So we're gonna remove base, do handle collision, handle animations, handle movement, and what else was there? Let me check. Flip. We need to handle flip. Let's pick the flip and make sure it is protected. Okay, do that. Close it. Go to enemy and do handle flip as well. Now, if I'm not mistaken, enemy is supposed to move. The only issue with this might be is that if we make enemy walk to the left, it will flip the visuals and transform, but it will not flip walking direction because facing direction will be equals to 1. To fix that, we need to go to entity and make flip function change facing direction as well. We just do facing direction equals to facing direction multiplied by -1. So if it was 1, it will become -1. If it was -1, it will become 1. Just like that. Let's save this. And if I'm not mistaken, even now, enemy is supposed to be able to walk around. Let's go back. And let's give it rigid body 2D. Let's make sure we freeze rotation on the Z. Gravity scale can be 3.5. And let's add capsule collider 2D. Gonna focus on it and try to set up collider correctly. Like that. Sorry. Like that. Yes, wonderful. We need to change layer to enemy over here. And now this object only. Do we need to do anything else? For now, this should be good. Let's test it. And enemy is walking. Perfect. It's not gonna attack or anything. It's just gonna walk. But anyway, it's good enough to have something working. But anyway, it's very cool. We can collide with enemy. Let's quickly fix that. We need to go to the player, give it player layer. So we're gonna do player, select the player, then change it to player over here. Now this object only. And now let's make what is target enemy. And for the enemy, make what is target player. Okay. To disable collision between objects, you need to go to edit, project settings, physics 2D, find intersection between player and the enemy and uncheck it. And that's it. You close this and now skeleton can pass by the player. All right, this is good. Let's go to the next chapter. Hey yo, In this one, we're going to make skeleton attack the player and make player attack the skeleton. How is going to be done? We have this attack radius. We need to fit it with animation skeleton has. For that, we need to make animation first of all. Almost forgot that. So let's do create new clip, animations, enemy. It's going to be enemy attack. Let's save that. Go to attack graphics, and well, it needs to be cut. Let me double check how I did that in my prototype so we don't waste much time. And over here we have 43 by 37 with pivot point 35 and 43. Why do we need pivot point at all? Why do we need to change it? You should know that. Let's do cut first. If you want, you can just observe me first, okay? We're gonna do read by cell size, 43 by 37, slice, apply. For now, this is it. I'm gonna take these sprites and drag them here, sample rate 12, and look at this. When I try to play animation, skeleton is going to place itself on a different spot, like that. This is because of the pivot point, because for these sprites, center of the object is over here, not over here. Because of that, when you play animation, image is moved to the left and down. To fix it, we can adjust pivot point on each object. I have a reference. It is 35 by 43. So this is what we're gonna do. We're gonna go to cut, choose custom, 35 by, I forgot. Imagine that, 43, okay. 35 by 43, slice. Now, pivot point for them is closer to the center of the body, same as we have it on the idle. Let's go back. And now if you go to idle and then go to attack, it's not going to feel weird. It's going to be smooth and nice. Okay, so when skeleton starts the attack, it's supposed to stop movement. Luckily, we already have that logic on the player. And this is where inheritance comes in play very nicely. We do need to attach events to the skeleton, right? So we need to attach this script. But before we do that, let's go ahead and change the name over here. Just to maybe entity animation events. I'm gonna put underscore. So entity acts as a prefix for something like entity animation events, entity health, entity combat, right? Then this should be changed to entity. And this is good. Maybe this one damage targets. Wonderful. Very, very cool. Now this can be used both for player and the enemy. We go back. Okay, we go back, attach it to the enemy, and then in the beginning of the attack animation, we add event, we disable movement and jump. Then we find a place where we should apply damage. I'm assuming it is over here. We add event, damage targets. Then we go to the end of the animation and allow movement over here. Enable movement and jump. Now, before we go further, because we changed the name of a method, it may not work on the player. So let's go over here and do player attack, find this event, and choose function damage targets. Okay, perfect. Now back to it. On the enemy, we've got animation with events. And now we need a way to transfer to this animation when we are ready. Let's go to Animator, make a trigger named attack. And you transfer to enemy attack when this trigger is called. For that you make transition, select it, and choose condition, attack. Go to exit time and then check exit time and duration. Thanks to this, transition to attack will be immediate. But transition back from the attack to move should have exit time. And we should use no condition, no transition duration, and exit time should be 1. In this way, animation will be played once and then it will go back to idle. And because we allow movement only when animation is finished, it's gonna work nice and pretty. Okay, perfect. Let's go back to the scene. We have trigger on the enemy. Now we need a way to make this trigger work. We do have try attack function on the entity. It's called try attack. Wait, it is here. Yeah, it is here. Sorry. Try to attack. So maybe let's change the name because it's going to work a bit differently now. I'm going to try to do handle attack. Okay. And for the player, it's going to be just like so. And I think we should do a bit of a cleanup later on and move player related functionality to the player script. Not like it will change the logic or the way it works, but just to give you an example of a bit cleaner approach. Okay, we're just gonna leave that task for later. All right, so we have this. Now we can go to enemy and override handle attack. Then we can call this function over here. And because we're overriding it and changing the logic, it's gonna do whatever is written in this function, not what is written in entity function over here. For enemy to attack, we should try to detect player. Basically, it should be if player detected, anim set trigger attack. This is how it should be, right? But we don't have any detection for the player. If you remember, I asked you to make handle collision as a virtual function over here. This is needed so we can override the function and add more logic to it. To detect player, we're going to use this attack checkpoint. This one. We're basically going to check if player entered this circle. For that, we need to make sure we have attack radius and attack point as protected. And we do have. I did it. I just did it and I completely forgot about it. Okay, we have it as protected. Perfect. Let's go to the enemy. Let's make a private bool player detected. Just that. Then we go and override. I'm gonna do it below. We override handle collision. Now in the handle collision, we do have ground check. And we don't really need to have this on the enemy, to be honest. I see no reason to have it as for the project we're making now. But maybe you will decide to twist a little bit and, make gaps in the platforms, and then you will have to use ground detected. So let's not remove the base. Let's keep it as it is, and let's just add functionality here. We're going to do this. Player detected equals to physics 2D, and we're going to use overlap circle. It suggests me these variables because I just made very same in my prototype over here, right? So what we need here is attack point to know the point of the circle we're going to use to detect collider. Then we use attack radius, will make things easier for us. And just to make sure we're detecting only player, we're going to use enemies what is target layer, just like that. Now in the handle attack, you simply do if player detected anim set trigger of attack, just like that. This is supposed to make it work with only one exception. There are going to be no damage, but that's okay. Let's go ahead and see it. We go back, make sure on the enemy you have what is target player, and make sure on the player, give it a second, make sure on the player you have layer player, okay? As for enemy, maybe we should check attack animation. Well, seems about right. Maybe you could make attack radius slightly lower, like just 1, to make it a bit more fair. And let's go. We go to play mode. enemy walks to the player and then attacks. Okay, there is an error message. Let's see, what is it? Oh, because we did not implement any logic for take damage. Let's comment this out for now and just leave it empty. And let's go. An enemy walks to the player and attacks. That's what I see. Perfect. I love it. Can attack. Okay, now we obviously can see there is no visual feedback on the attack, which is fine because we did not make any, but usually you do a bit of a flashlight or something like that. I do show it in a full RPG course, but also I think I'm gonna make like a short YouTube tutorial showing only how to make attack feedback. So just when you're doing this tutorial, check out the description below. If I made a tutorial, it will be there. And I do have plans to make it, so I will not leave you hanging, okay? But maybe it will take like some time to do. Okay, wonderful. We have the attack. Now I think we're gonna end it here because I want to like break it into chapter. And let's go to the next chapter where we're gonna set up damage and death. Hey again, and in this one we're going to make damage and death logic for this mini game. It's gonna be quite simple. By the way, let's clean this up. Let's do graphics folder. Take this, drag them here. Okay, so it's going to be quite simple to implement. We have to go to the entity script and make like a header health maybe. I think it can be private for now, so let's do private int max health. We're going to use integers for now because we're only going to need to do one attack to kill the skeleton. And then we're going to do private int current health. Then we go to the awake and set up current health equals to max health we have. So over here we do we do current health equals to max health, just that. Then we're going to take damage function, in which we do current health minus, what should we do? We should do -1, just that. So each attack does 1 damage. And then if current health is less or equals to 0, you should kill the entity. How do we kill the entity? We want to make a protected virtual void die function and then call it over here. We're doing it this way because some of the logic for destroying object can be the same, but some of it should be different. For example, when player dies, you're supposed to open UI saying game over, right? That's the idea. Let's go ahead and make something cool for this one. I don't want just to destroy the enemy. I want them to fall off the level. I have a code snippet I used in the main course, so let's use that. It's very cool over here. So what we're gonna do is we're going to do anim enabled false. This will disable all the animations entity has, and if you kill skeleton while it is attacking, it's gonna die in the attack frame, which looks very cool. Then we want to disable collider to make it possible for object to fall down off the level. So let's do protected collider 2D collider. We're gonna get it in the awake. Collider equals to get component of a collider. And then we go here and do collider enabled equals false. All right. This will disable collider so object can fall off the platform. Then we take rigid body, linear velocity, and we give it a bit of a vertical velocity so it will bounce up a little bit when you kill it. We do new vector 2, rb linear velocity dot x will be unchanged, and for the y we can just give it like 15. And then we increase gravity scale so it will fall faster, but increase gravity scale before you give it a velocity. It will make bounce more bouncy. Yeah, just like that. And I think this is good. Let's save this. And this will work both for player and the enemy, so we don't have to go to the enemy over here and do anything. We can just leave it as it is. Let's go back. I'm gonna give player more health, like 10, but for the enemy it can be just 1, it's fine. Again, we don't really have a visual feedback on the attack, which I really want to make, but now we have a different focus. Okay, first of all, we can see enemy does not come close enough, or it is close enough, and we do getting damaged. We really need some damage feedback. Let's see it again. Cool, we're killing enemies. Now, this is done, but I do feel like it's not good without visual feedback on the attack. So this is what I'm gonna do. I'm gonna show you how to make visual feedback in this video right now, but I will not explain it like with details, okay? I'll just give you like a brief explanation and the code we should have. And then proper explanation you're gonna get in the video I'm gonna attach to this lecture when I make it, because I specifically want to make like a visual feedback video as a separate video that people can watch, like 2-3 minutes video. So let's end it here. Let's go to the next chapter. Hey, and we're doing visual feedback. So what you can do is you can make a material. Let's go to materials folder. And over here you can make a material. Let's call it damage feedback material. Go to shader and change it to GUI text shader. Now because you have it, you can go to sprite renderer of any object and assign it to material over here. And when you do that, it's going to become completely white. If we do that for a split second, it's going to look like a damage feedback, which is really nice. Really, really nice. So let's go to entity, script, and we're going to need access to protected sprite renderer, SR. All right. Then we need to get this component in the awake. So let's do that. SR get component in children. Don't forget, it is on the child game object. And now we need to make a function that would change material to damage feedback material, wait a little bit, and then change it back to original. This can be achieved with the help of a coroutine. Again, I don't want to dive into coroutines right now. If you want to learn about coroutines, I do have a video where I talk about them, as well as other ways of making cooldowns, so you can check that out. I'm gonna attach it to the description. But to put it simple, coroutine allows you to pause functionality for a certain amount of time. Let's do serialize field. Serialize field, private material variable, damage material, okay. And then we do serialize field, private float, damage feedback duration. 0.2 is usually enough. And we want to create a, sorry, what is it? Yeah, we want to make a private coroutine. Damage feedback coroutine is fine. Let's name it that. We need this so we can store active coroutine into a variable. The reason why we need to store it into a variable is you can run multiple coroutines at the same time. If you're getting damaged multiple times, you will run multiple coroutines. And if you do that, it can mess up the functionality and the feedback visuals. So we can store it into a variable, play it when we're getting damaged. Then if we're getting damaged again, we stop the active coroutine and start a new one. That's the best practice. Okay, let's go down to take damage function. And over here, you make private IEnumerator. Let's name it as damage feedback. And usually it's a good practice to name coroutine as a coroutine. That's what I usually do. It helps me understand the code better. And you could do coroutine here fully, but I don't like it this way because I never can spell it correctly, except that I did it now, right? I'm not sure. So I can never spell coroutine correctly. So what I do is I type just damage feedback coroutine with the shorten CO. If it's consistent across the entire project, then it's fine to do that. Then over here, first of all, we need to get material that we have on the object right now. So we do material, current, no, original material. So we can store it and restore original material to what it was. Okay, we do original material equals to sprite renderer material. Then you do SR material equals to, and you make it equals to damage feedback material. So damage material. Then you make a coroutine wait. This is how you do it. You type yield, return new, wait for seconds of damage feedback duration. And then after you waited enough, you do SR material equals to original material. Just like that. Now you can see it is underlined, even though not supposed to be, because we do have using system collections, but let me see, why is it? I'm gonna press Alt Enter. Oh, we need to do using system collections as well, okay. Okay, so this one is not needed. All right, now we do have a coroutine, and when you want to call the coroutine, you don't just type a method like so. What you actually need to do is to type start coroutine. So this is what we do. And it should not be in this if statement. It should be here when you reduce the health. You do start coroutine of a damage feedback coroutine. And as I told you before, we need to stop the active coroutine just so we don't run multiple coroutines at the same time. So what we do is if damage feedback coroutine is not equals to null, then stop coroutine, damage feedback coroutine, and then you start a new coroutine. And now because of all of this, it looks a little bit messy, so I'm gonna extract method and call it damage, maybe even play damage feedback, like that. Now it's a bit cleaner, and this is the code we have. Take a look. Now you save it, and let's go back to Unity. Take the player, click material, choose damage feedback material, then go to enemy, choose material over here. Now I'm gonna give skeleton a little bit more health just so we can test the visuals. We go here and do like 10 as well. Now when you damage the target, it's gonna flash with white, which helps us understand that we got some damage. Check this out. Yeah, maybe we can make it slightly more brief. Let's try 0.1. Yeah, this is better. And of course, if you want to go further, you could stop the movement, maybe give a bit of a knockback, or actually this is what we do in the RPG course. You can give it a knockback, you can add another visual effect on the top, whatever comes to your mind. Let's do 0.1. Enemy 0.1. And I'm gonna give it 1 health and try to fight it. Damages me, I can see it. I'm gonna damage this one and it goes down. Perfect. Well, this is it for now. Let's go to the next chapter. In this chapter, I want to improve game visually. I want to make it look better. You can go to itch.io and find a background you like. Assets over here. You can just go to free, choose backgrounds, and scroll around, find what you like. I suggest just taking this one, Pixel Forest. It's really amazing graphics. So I'm gonna take this one. If you want to, you can scroll down, find something that works better for you. So let me take this one. Download now, no thanks. Download. We're gonna open archive. Gonna cover this. And I'll open this. We're gonna take PNG and just take background layers, drag them to graphics, like that. Then I will open it, and I kind of like the distance of the camera here, so I'm not going to change it. We simply need to take backgrounds, do compression none, no filter, 32, so we have some sort of a standard across the project. And then we take one of the layers, let's say, let me see. We need like a layer that is visible on the entire screen so we can imagine the scale of the object we need to have. Let's say this one. Let's drag it into the scene. Oh no, this is wrong. We need to take only one. Why is it only, what is happening? I'm sorry. It is multiple sprites here. Okay, we're not going to manage multiple sprites. Let's make them single. I'm not ready to spend like lots of time on this one. Okay, we drag it into the scene like that. Now we have part of the background. This is too small. We can see edges over here, so we need to fix that. Let's go ahead and try to make it bigger. Maybe 2. That's a bit too much. Let me try 1.8. What's up? Oh, there. Okay. 1.8 seems almost perfect, but actually I know this asset and we're going to have like a part of the grass over here. So I think 1.8 is actually fine. Let's try that. If anything, we can always increase the size. So what I'm going to do now is I will make an empty parent for this object, and it's going to be called background. Then we're going to leave it here, and we're going to take another sprite over here. Probably this one, 0, 0, 0. Okay, we're going to drag it into the scene, make it as a child of a background as well. And the scale was 1.8. So we take this object and make it 1.8 as well. Now it went somewhere there. Okay, we have it. And we need to take this grass and move it higher. So as you can see, it will cover up part of the background. So it's fine if we have gaps over here because we can cover them. Now, one of the obvious issues you can see here is that the ground, the grass that's supposed to be in front, if you want to see how it's supposed to be, you can take a look at the asset link. Right, this is how it's supposed to be. So it's supposed to be in front of the trees, not behind, as we have it over here. To fix that, we usually use sorting layers. You go to sorting layer and add a new one. And with the help of sorting layer, you can tell Unity what should be drawn in front of what. For example, we need to have background, and we need to have a layer for player, enemy, basically characters. So let's do characters, right? When you have bigger project, it's usually a deeper setup, but for us, this will do. Now we go to background and choose sorting layer background. You can see we now cannot see platform and the player, and that is because of the arrangement order over here. If you want to give priority to something, you should move it below. So if we want background to be behind of everything, you move it above. Then you should have characters and then default for anything you add into the scene so you can immediately see it, and then change the layer to what you need. Okay, so we choose these two and they are both should be background. But now, because they're both on the background, we still have a weird behavior where grass is behind the trees. To fix that, you usually go to order in layer, and the lower value is, the less priority it has. In this case, we have 0, 0 as a grass, and I think we should keep it at 0. Then we go to layer 3 and do -3 over here. Now it is behind. Now we can take this knowledge to set up entire background. Let's go to graphic, background. I'm going to just collapse it because we can arrange them using numbers. Import this one, do 1.8 on the scale, background, and this one is -1. Then take it and move it higher. It will be behind the dark grass, but in front of the trees. And it's supposed to be somewhat like so, maybe. Yeah, we can take them both, move them a little bit lower, and basically set up them as you like. Honestly, only up to your personal preference. Something like this should do, I guess. Yeah, looks cool. Maybe a bit higher, I don't know, like that. Let's see everything. Now let's take the second one, drag it here, scale 1.8, background, -2, and this one is the top part of the forest, so you move it above. Sorry, let's make it as a child and move it above over here. Here it's up to you how you want to have it. You can cover half of the screen to make it like more closed, right? Or you can just do a bit at the tip over here, which also works just fine. Now I want to save some time, so I'm gonna import everything that's left. 5, 6. We need to do one by one because otherwise it will offer you to make an animation. And maybe except these two because they don't really do anything. I checked. Let's take them over here as children. This is duplicate, we don't need it. Select other stuff, do 1.8. Certain layer background. Let me see. What do we do next? Let's switch them off and enable them one by one. These are lights, -4. If you want to have lights in the forest, you can leave them here, but I think I'm gonna switch it off for now. Then we have number 5, which is this set of trees. We do -5 on order layer and drag it above over here to add dimension. Looks very cool, by the way. And you can place it here, place it here. Honestly, see what you like about it and just choose something. Like that. Okay, then we take a look at number 6, -6, drag it above, like that. Number 7 are lights. Again, if you like them, you can use them. They're quite cool. Maybe with the light we can do open sprite editor and do multiple and slice. Yeah. And we can use, how did I do it? Wait a second. I did not understand. Multiple, open sprite editor, yes. Slice automatic, apply. Okay. And over here you can just take one of the lights. The first one, place it here, maybe make it bigger, like that. And we're gonna have an object in the center that we need to protect. So you could point light at the target you need to protect. That could be very cool. Like -4 maybe, like that. Let's see when we have the target. Number 8, -8. Place it there. Looks good to me. And number 9, -9, just a fog, forest fog. Like that. And you have pretty background. Now you need to take platform, move it down, just so you can arrange it like to the level of the grass you have over here. Maybe if you want to, set it on a background with -2 so you cannot see it, and then it will be easier for you to set up because you can just see the point, I mean the top part, and stop when you need. So like this, right? Then I'm gonna make it longer over here, and I will disable sprite renderer because we don't need visuals. Let's change it to ground, and now let's take ground and background and give them common empty parent and call it level. Now we have level arranged in a pretty way, and you can go ahead to the game and run around, and you can see the forest, trees, everything. Sorry, I did it in a bit like in a rush, I know, but this part is quite boring to do, so I thought just speed up the process and show you everything quickly. I hope you don't mind. Now you can see Skeleton walks away from me. Don't worry about that because we're gonna have a target and you will have to protect the target. And if skeleton does not attack you, then skeleton attacks the target. That's the point. So that's why we have it walking away. If you wanted to, come back, flip around, chase the player, that is a more complex behavior that cannot be covered here. Okay, very cool. Very, very cool. Let's end it here and let's go to the next chapter. All right, in this chapter, we're going to do something very simple. We're going to make a target that we will place in the center, and you need to protect this target from the enemies. If enemy damages the target, you lost the game. I found a very pretty asset on itch.io. It's this girl over here, but not too, yeah, it's a top-down view, but it's okay. We only need idle sprite, so it can be used for us. I don't want to have like lots of links in the description, so I'm gonna attach it on my Figma board over here. And you can find all links collected together. Yeah, it is over here. Simple top-down character by Immunity. Or if you want to just take a look at the link and search it, it's called Simple Top-Down Character. Okay, so I'm gonna take it. It's the same link. Oh my, okay. Sometimes brain is just not working. Maybe I'm hungry. Let's download. Let's open. We only need the last one. We don't need arrow and a bow because it's going to be an idle character. Let's take it and drag it to graphics. And I know it's a girl, and we're going to use it like we're going to use a small scale so it looks like a child, but we need to be a little bit technical about it so we know what the object does in the game. So I'm going to call it object to protect graphics. Okay, let's do compression none, filter mode no filter, 32, so we are consistent. Actually, in the graphics it can be like a girl graphics, but in the code it should be something like object to protect. Let's open sprite editor, and over here we have lots of sprites gutted, and you cannot just select them and delete them. You need to select them one by one, but that takes lots of time. So we're gonna do slice by cell count, and we're just gonna do one by one. If you do that, you're gonna have only one cell that you can easily delete like that. Then we go ahead over here, find the sprites we're going to use. You can use the one where she looks at you forward, but I think it's better to use the side one, and then we can just flip it. So let's do 24 by 24, another one, another one, like that, and one more. 24 by 24. Okay, these four should be enough. We don't need the other direction because we can flip it. Actually, by default, we have all facing directions to the right. So let's use the one that are to the right. Okay, like that. One more. 24 and one more. 24. Apply. Perfect. Now we need to make a game object. Let's start with that. We're going to take one of the images, drag it here, name it is Animator. Let's place it next to the player and see what size should be. This is too small, so maybe like 1.75. Yeah, looks like a baby. Very good. And we need to protect it. I love it. Let's change sorting layer to character. Then create empty parent. Call it object to protect. Would be nice to call it with single word, like they do in League of Legends, like Nexus, right? But it's not the Nexus, so it's okay. We need collider on this one. It should be like that, maybe. Then we need rigid body 2D, freeze rotation Z, it's important, and place it somewhere in the center of the level like that. We don't need to have a script over here as well, but let's set up animations first before I forget. Okay, let's go to Asset, Animation Controllers, and make a new animation controller. It's gonna be object to protect. Maybe I can just do underscore girl like that. Now select Animator and assign it over here, and then go to Animation, create new clip, go to Animations, and I do have it, but I'm gonna delete it and make a new one. And I'm not gonna make a folder because it's just one animation, so it's fine. That, yes, replace it. I'm not recording this for the second time, it's the first time. Yes, honestly. Okay, let's take these 4, drag them here, sample rate 6. Maybe slightly faster, like 8. Yeah, looks okay, very dynamic. And this is it, we don't need other animation on it. Now we go to what? We go to object and we need to add the script. Let's go to script, and we could just drag entity, but I want to make the girl look at the player when it moves. So I'm gonna make a new script, object to protect. Let's find it and let's inherit from the entity. If you remember, I showed you how you could change the logic of the handle movement so you can pass parameter. I think we should do it for the flip functionality. It's the easiest way probably. So we go to entity and we have a handle flip function, handle flip over here, and we flip in according to the X parameter. What we can do is pass player's position to object to protect, and it will flip according to the position of the player. Oh wait, we cannot pass parameter, we need to override the entire method because we cannot compare it to 0. We need to compare it to actual position of the girl itself. Okay, so let's do protected virtual void then. Save it, go to object to protect. We override update, we remove the base, and we call handle flip over here. Then we override handle flip, pick definition of the flip, because we need this script over here. Copy this, close it, paste it in. And what we need is flip not available? Okay, my bad. Let's make it as protected. And let's go ahead and make facing right boolean as protected. Very cool. Gonna save this, go over here. Now we have parameters, and what we should do is we should compare transform position of the player to transform position of object to protect. But we do not have player anywhere. Usually how I search for objects in entire scene is I use player's component to find object in the scene. But as of now, it will a bit of a derail from what we're trying to do. So I'm gonna make a manual reference, and then I'm gonna do cleanup and show you how to get reference without manually assigning it. But as of now, let's just do player here. Okay, we're gonna assign it manually. And then we're gonna check player transform position dot x to transform position dot x. Just to make it clear, this is position of the player, and this is the position of the object to protect itself. Now do same over here. And transform position.x. Now it's supposed to flip and look at the player. This is how you can set up NPC in your game, for example. Let's go back. We attach it over here. we don't need attack point really, but if we don't assign it, we're going to have a null reference exception. You have two options on how to deal with this. You can either just assign the object itself and forget about it, or you can go to the script and do if attack point is not equals to null, then you draw wire sphere, which is also okay. Let's go back. I'm gonna remove this. We don't have a target on object to protect. We do have damage material. Duration is 0.1. Max health, let's say you can, this basically defines how many hits you can miss before you lose the game. So let's say 10. We also don't need what is ground really, but what we do need is a player, and maybe we need a header to make it easier to see. So I'm gonna do header extra details, I don't know, should be fine. Okay, let's assign the player. This is not important for the girl, so it's fine. And if we change layer to the player, it can be targeted by skeletons. So let's change it to player. And maybe let's take care of the visuals. So we have character over here, it is 0. But now player is in front of it, so it's fine. Maybe just to make sure player is in front of the, or should we, wait, how do we want to do this? Let's make her visible at all times because it's a priority target. So let's go to object to protect animator and do sort in layer and do order in layer 10. Then for enemy you can have character 0, and for player you can have character 1. So now player will be in front of the enemy and object to protect will be in front of the enemy and the player. Now let's take this. Let's take a look at this. Place skeleton here, and we go to the game. Oh, that should not be like that. Let's go to project settings, physics 2D, find the intersection between player, and disable it. Okay. Now I can pass by. Girl is flipping and looking at me, right? And skeleton comes there and damages the girl. And you can see she's losing health points over here. And now we need to make a game over when object to protect has 0 health or less. But that will come later. As of now, let's just go to the next chapter. We need to do something else. In this chapter, we're going to do cleanup in the code we have. So some of the things I did were done just for the sake of easier explanation. But actually, it's not the best way to do it. I'm gonna show you what I mean by that in a minute. I also want to say that some of the things were done this way because originally I did not plan to complete this project. This is part of the crash course for the Ultimate RPG course I have, and there I only needed to explain the basics on how to work with components, like collision detection, all of the stuff we learned basically so far, right? So I needed to explain that and a bit about object-oriented programming, just so my students are ready for the main part of the course where we do create RPG game with systems and so on. But then I told you that I decided that it's not enough for a YouTube video and I want to make it somewhat completed project. And then I decided to pivot. In this case, I had a bit of a struggle to see how could I explain it and not touch code too much at the same time. And that's why I decided to keep some stuff untouched in the entity class. But actually what I did here is not the best practice. I'm talking about things like this, for example, handle input. We do have it on the entity because originally entity was a player class, right? But enemy does not use handle input at all. So actually what we should do is create a player class, inherit from the entity, then keep everything on the entity as it is, except things that should be used by the player. If you have a function, let's say like this one, that is only used by the player, then you should create a player class, inherit from the entity, and take that function and move it to player class. I guess I mentioned it before that we're gonna do cleanup, right? That's the purpose. Also, let's say this one over here. Entity is not using try to jump, enemy is not using try to jump, only player is using try to jump. So now we will have to do a bit of a cleanup and refactoring to make it all as it should be, right? Because otherwise I will not sleep well. I'm sure like overall it's fine. It's not a disaster, to be honest. It's not even the worst case I've seen, right? It's just like it's like I'm telling you, it's about dignity. You know, I cannot leave it like that. So we have to adjust it and make it right. But I don't want you to feel like we're doing an extra work here. Actually, we don't. We're gonna do refactoring and cleanup, and it is very important skill to know. It's very important to understand how you can clean up the code and change things for the better. And this is what we're gonna do. Try to catch up. I'll be slow about it. I will explain everything. But refactoring is usually super confusing to watch, I know from experience. So just try to keep up as best as you can, and let's begin. Now we're going to make a player class, player, and player will inherit from the entity. Remove start and update. Now first step is the movement function. We do have it here like so, and it uses X input, and only player has the input. So what we need to do now is to take this script, you just cut it and you keep function empty. It's okay to keep it empty like that because we overriding it for enemy and for the player and giving it a certain functionality that we need to have on those entities. So on the enemy we do have handle movement like so with facing direction, and on the player we go override handle movement and paste code in here like that. Now, make sure you don't have this using Unity Engine Windows. This is weird. I'm going to remove it. And only thing we need is X input, which is supposed to be on the player only. So let's go to entity, take the X input variable, cut it out, go to player, paste it in, just like that. This is already so much better, honestly. Now there is more stuff to do, but before we move to them, let me show you something. On the entity over here, we do have move speed and jump force. And jump force, as of now, is used only by the player. We do have it here because, again, originally it was a player class. But now we do need to have jump force on the entity. So logically, you take this one, cut it out, go to player, and paste it in over here. Now when I do that, I will get an error message on the entity because we do have this function try to jump, which also supposed to be only on the player. So I'm gonna cut this out as well, go to player. Now when I do that, you will see I have error with the can jump boolean. So we go back and we get can jump boolean out of here, cut it out. We don't need it on the entity. It is not used by entity. Again, it is not used by the enemy. It is used only by the player. If that's the case, it should be only on the player. So let's go here, paste it in. Okay, now we don't have error messages here. This is good, but we do have message over here on the input. Here. We do need to take care of the input as well, but in a minute. Before that, I want to show you something. Look at this. We've got move speed with the movement details on the entity, which used both by the enemy and by the player, right? So it's fine to keep it there. The problem with this one is if you go to Unity and attach component of a player over here, what is it? Okay, let's comment this out for a second. Let's go back. So if you go here to the entity, remove component and attach player component, you're going to have the component and we're going to need to update setup. Let's do it now actually. Damage material, max health 10. What is enemy? Enemy, attack point, attack radius 1. Right? Seems okay. what is ground? Ground check distance 1.45. Yeah. So the problem here I see is that move speed is over here and jump force is over here. And to me, they are connected. They should be under the same header. It is fine for the enemy because enemy has only move speed, but for the player, we did add jump force. And we cannot force it here because it's on the new class. And this is just the structure that Unity follows, right? Variables are placed below. So over here, for the sake of clearance, for the sake of clarity. So over here, for the sake of clarity in the inspector, I will create same variable on two different classes. So this goes like it goes as an opposite to what I said before. If you have something that should be used by multiple classes, you make it on a parent class and you inherit and use it on those classes. That's how you usually supposed to do. But this time, I deliberately make an exception for the sake of clarity in the inspector. So this is what I'm going to do. I'm going to cut this out, go to enemy, paste it in here. And then I'm going to go to the player. Let me copy this. And on the player, I will paste it in here as well. So now I do have same variable on two different classes, and I do not have it on parent class, but it's fine. Because if I save this, and this, and this, and go back to Unity, I will have a proper arrangement in the inspector over here. You can see I have movement details with a move speed and jump force. And enemy has move speed over here. An object to protect does not have move speed at all, but it's okay, it's not using it. So in my opinion, it is a better option to do it like so. All right, let's continue cleanup. Let's go back. And what we did before over here is we removed base of the update and we called all the methods in the update over here, everything except the input, which is okay, but could be done better because we know that both enemy and player are using collision detection, animations, handle movement, and flip. So these four are used by both of them. That's why we have to go to the entity and just keep what we have here, except the input. You remove this. Okay, you remove the input, and this is your base update. Now you go to the enemy, and on the enemy you do base update. Your base update contains collision, movement, animation, and flip. This means that you don't need it here after the base. You don't need collision because you have it in the update. You don't need animations, you don't need movement, and you don't need flip. You only need to add whatever is used by enemy over here after the update. And same should be done on the player. We go to entity, take this input function, cut it out, go to player, paste it in here. We can now uncomment this, I suppose, and override update, have the base, and add handle input. This is the proper way to do it. Again, I'm sorry I did not do it in the first place. It is a development, sometimes it does not go as planned, or sometimes your plan changes and you have to adapt. But this is the proper way to do it. You have whatever is in common between two classes in the base, and whatever you need to add, you add after the base. Perfect. So now we have input only on the player, we don't have it on the entity, and we do have base on the enemy, and we handle attack in the update only on the enemy. Perfect. I feel like I was talking a lot. Anyway, now let's see the entity class. We did change this can jump boolean, but we don't have this boolean parameter on the entity anymore. So what I'm gonna do is I'm gonna cut this out and make this as a public virtual void. Okay, we save this, and on the player, you override that function. And then after the base, you add can jump enable. This is the proper way to do it. This is how you do object-oriented programming. I think we can change name of this function to enable movement, because now it makes more sense to have just that. I'm gonna do enable movement, right? And it should be fine. So on the entity, you have only enable movement, and on the player, you have enable movement and can jump equals to enable. Perfect. I just realized we don't destroy the object when it dies, but it's important to do so. So let's do destroy game object, and we can give it a delay. So let's give it delay of 3 seconds maybe. It's enough for object to fall down far away from the level. Okay, let me see. Let me take a quick look again, okay? This is fine, we do use it. This is okay, this is more about damage and health, so we can keep it here. Let's make this 0.1 by default. Then attack radius, this is good. This can be moved down below the collision, just for clarity. Facing direction details. Then awake is fine, this is how it's supposed to be. Update is good, damage targets used by both, so it's okay, we can keep it just like so. Take damage is the same, maybe we can do this. And we play damage feedback, this is good. Then there is a coroutine for the feedback, and then there is a die function. Maybe we can place die function above, like that. It's not necessary, it's just personal preference. Then we have enable movement function, handle animations, handle attack. Good, good, good. Handle movement, it is empty, but it's okay. We override it on child classes, so this is good. Good, good, good. I think it's fine, we cool. Let's go to enemy, double check this one. It's all good so far. I don't see any problems here. So I'm gonna leave it. Object to protect. Over here we do face the player, but it may happen that you will destroy player's game object. So let's do this. If player is equals to null, you return. Okay? So it will not give you a null reference exception error in the Unity. And also I told you that I usually look for game object by checking the component if I can. And now we do have player component on the player, and we can use that. Let's remove this completely, and let's see if we can override awake. We cannot. Okay, let's go to entity and make this as protected virtual void awake. Okay, you do this, and now on the object to protect, you can override awake. Actually, I just realized I was wrong deleting the variable. I'm sorry. We can just do private transform player like it was before, but it's not serialized field. And then after base of the awake, you do player equals to find first object by type. And this will search the objects, and it will find object that has player component on it. Then we do dot transform. So we search for the first object with a component of a player, and we get in transform from it. And because of this, we don't need to assign it manually. It will be assigned automatically. Don't use this in the update, and don't use it frequently, like when you attack or something. You can do it once or twice when you just start the game to initialize something or to find reference, but otherwise, better set up reference in a different way. Okay? Yeah. Okay. If you're using Unity 2022 or before that, then you should do find object of type instead. Okay, this is good. On the player, everything seems very cool. I like it. Nothing else to add here, so this is good. Let's end this chapter and let's go to the next one. Hey there, so I know last chapter was quite long, but it's okay. We really need to do cleanup in the project whenever we can. And now it is all so much easier to manage. Yes. Okay, so what we do now is, like, we have two goals. We need to respawn enemies, so game becomes harder, and we need to make timer and game over UI. These are very simple. We are very close to the finish line. Let's do UI first. Why not? So this is how you make UI. First of all, you need a script so you can manage things. So we're going to do UI class over there. Let's keep it empty for now. Let's go back. And then we make a canvas. You do UI canvas. You need to expand this one over here and change scale mode. The reason is we need to choose scale with the screen size. The reason is simple. When you choose this one, Unity will adjust UI elements automatically according to the screen size the game is played on. Otherwise, if you have huge resolution on the computer and if you set small UI elements, they're going to be super small. But if you do scale with the screen size and give it reference, let's say 1920 by 1080, then it's going to automatically adjust size of UI elements. Now, what do we want to have here? This game is pretty simple. We don't really need much. We only want to have maybe a timer over here, so player knows how long they hold the defense, and maybe count of skeletons killed if you want to do that. I'm gonna show you how to do that, why not? And then this is it, right? And then we need game over screen that gives you a try again button. All right, let's do that. Let's make UI. Let's do empty object. It's going to be in-game UI. And, you know, for the record, this is going to be a very simple UI, right? So we have empty object. What we want to do now, where is it? It is over there. What we want to do now is to click over here, hold Shift and Alt, and click this icon. This will stretch in the object, and it will make its size same as the size of the screen. This will help us to arrange UI elements properly. Now let's do UI image in game timer and how it should be done. What do? We need some font, right? We need a pretty font, we need a text, and we need another image. Okay, this is what we're gonna do. We're gonna make another image, UI image, timer background, and this one will be black, like that. And we move it to the right. So I want to write timer, and here will be the number. Maybe we can take the parent, make it longer, like that, and create the text, UI text mesh pro. Now it will offer you to import TMP essentials. You do that. It will take a second. This one is not needed. We can close it. And now you will have this folder for Text Mesh Pro that is used in UI elements. And over here, we can change color of the text to black. Let's do timer text. Okay. It will just say time. Why not? Just that. We can take the timer text and attach it to the left border of this in-game timer game object. We need to go over here, hold Shift and Alt, and click on the left. It will be attached to the side. Now we do want to maybe align it and set it in the center. So let's go over here and do middle, and left side is fine. Maybe it's too close to the border, so we can select it and find the cube over here, and not this one, and just drag it like so. It will give it a bit of a space. Now I don't like the font at all, so we need to do something about it. I don't want to attach any fonts because it will, like, then I need to attach the file so you can download it. It's a headache. Let's do this. Let's do Google Fonts. You open Google Fonts, you search something you like. Let me try to find Pixel font. Well, it's not really a pixel. Oh, there is. Okay, this is perfect. I'm gonna take this one. You can find this one or any that you like. We need to do get font, download, you open the archive. I do have two for some reason, but it's okay. I'll just take this jersey and I will import this jersey 10 into Text Mesh Pro folder, like that. Now, this is a font file that you usually use on your computer, but it's not ready to work in Unity. To make it ready for Unity, you need to go over here, do Text Mesh Pro Font Asset Creator. Assign it over here, click Generate Font Atlas. It's okay. click Save. You can choose Text Mesh Pro folder and save it. Now, thanks to this, we can go to, it's keep popping up, I hate it. We can go to timer text and change font over here to Jersey 10. Okay, this is better. Let's see what we can do about font size. We can do auto size, why not? And we can increase the text box to something like so. Maybe that's too much, let me see. Okay, so height 50. And I want to make it pretty and slim, so I'm going to take this object and I'm going to make it, what do you call, taller, shorter, like that. Yeah. Now, again, this is not the best options you can have with your UI. I'm just using basic tools so we can do things faster. But if you do want to have prettier UI, I have a video where I explain where you can get UI elements if you don't know how to draw at all, right? How to get them and how to set them up. Some tips and tricks and overall resources that you could use. Basically, I explain how I managed to make UI I have in the RPG project you see on the screen. So yeah, you can check out that video. Or if you want to learn how to make this entire UI with items and everything, then you can check out the course that I will link in the description as well. Okay, back to this one. Let's make it shorter like that. Then let's take the background over here, reduce it to something like so. And let's make another text element over here, UI Text Mesh Pro. And this will be timer value. We set it to center and we attach it to the right side. It is not on the right side because of the alignment. So you go over here and do right. And you change font. And this one will show you numbers like 43 seconds, let's say, or 56 seconds, 0.42 seconds, something like that. So I think it looks fine. Or not. Let me see. It's not aligned properly for some reason. This is how it should be. And font size is not perfect. So let's uncheck automatic size and let's do 46. And on the timer value, let's do 46 as well. Now it looks good to me. I like it. Let's reduce it up to here and do auto size again, but sorry, maybe I confused you a little bit. You can do maximum 46 over here. So yeah, sorry, we do auto size and we set maximum 46. So in this way, you will have it as 46, but if you have a bigger number here for some reason, the font size will reduce itself and it will fit into the borders you set. Okay. Maybe let's deattach it from the side over here and let's go look at this text over here. It should go here and auto size maximum 46. Yeah, that's the way to do it. So now we do have a timer. We can attach it to the left top corner. You select in-game timer game object, go here, hold Shift and Alt and choose top left. Then you focus on it, press W, move it down a little bit and a little bit to the right, maybe more like that. Perfect, love it. Now we also need a kill count, and I think we can just duplicate this game object, attach it to the top right corner, check out X position over here, it is 25, so we go to this game object we just created, change name to in-game kill count, then go to X position and do minus 25. On the Y, it was minus 18. Let's do minus 19. And it should be same over here, minus 19. Well, looks like it's not enough. I'm sorry. So let's just take it and move it to the left manually until we like it. Now this should be kill count background. Kill count value. And let's say it has like 3 kills. Then text should say kill count. I should say like kills maybe. Just like that. If you want, you can switch color for them. Why not? Like you go and do this as white, and then background you go and do, wait, this one, kill count goes black. Then for this background you go and do white, and value you go and do black. Wait, this is wrong one. Value over here, like that. If you like it this way, up to you. Now we need to set up logic for these UI elements. We go to UI and we do a couple of things here. First of all, we set up serialize field, private text mesh pro, GUI, timer, text, reference, and serialize field, private text mesh pro, timer, kill count, text, reference as well. Then you go ahead and open update, and in the update you do timer text.text equals to, and we can use time.time. So time.time gives you time in seconds since you started the game. And in this case, it is perfect to use. So we do time.time, and it gives you a number, but we need to make it as a text. So we do dot to string, and we want to apply a format, because otherwise, like if you have a float number, let's say like 5 points this much, it will show you that much in the text. We don't want to do that. We only want to show one number after dot, or maybe two. To do that, you go ahead over here and type quotation marks F2. This will show you two numbers after the decimal. And we can do plus just seconds maybe. S over here. Very good. Now we also need to increase kill count every time we kill the target. So we're gonna do public void add kill count, which will simply do kill count.text equals to, we need counter, we need private int kill count. Sorry, yeah, this is what we need to do. We need to do add kill count plus plus, and then kill count.text equals to kill count to string, like that. Yeah. Now we only need to kill this, call this function every time skeleton dies. For that, we need to have access to UI on the enemy. But we're also going to need to have access to UI on object to protect and on the player as well, because we're going to need to show game over screen. So let's go to entity, make a protected UI component. Okay. And then in the awake, we do UI equals to find first object by type of UI. Wait, but we're going to instantiate skeletons, and then we're going to, every time we instantiate a skeleton, we're going to search for the object. So it's not very good for performance, but this game is like extremely simple. So it's fine to do it like so. Yeah, it's okay. Or if you don't want to do it, let's just do this. Let's go to UI and do public static UI instance. So this what you call a singleton. You can make a singleton, and it allows you to access the component from any script without getting a reference. The downside is you can have only one singleton of a certain type. So if you want to have singleton for UI, you can have only one singleton for UI. You cannot have two. This is how you make it. You go to awake and do instance equals to this. And now because we did it, we can save it and we can go to whatever place we want. Let me remove this on entity. Right, remove this and remove this over here. We don't need the reference anymore. And we can go to any place we want. For example, to the enemy, override the div function and do UI.instance add kill count. And it will call kill count function on UI. Okay, let's save this. Let's go back to Unity. On the canvas over here, we need to give it UI. Then we need to assign timer and kill count. We go and find timer value, assign it over here. And we find kill count value and assign it over here. And just to be sure it is working, I'm going to go to kill count and make it 0. Same I will do over here. Okay, let's go to play mode. And we do get timer updated. This is good. Let's kill the skeleton. Why am I so slow? I kill the skeleton and I get kills 1. Perfect. Very, very good. Let's make player faster, like 8 maybe. Was it 12 by default? It was 12, but I want to make it a bit slower, so 8 should be fine. Let's see. And now we need game over UI, but let's divide it into chapters, okay? So let's end it here, and then in the next chapter, we're going to make game over UI. In this one, we're doing game over UI, which is also quite simple to implement. We make an empty object, game over UI. And for this one, we basically can just make a text, game over text. Let's make it bigger, like 1000 by 200. And let's do auto size for the font. Place it in the center. Change font to pixel font we have. Maybe it could be bigger, so let's do 150 as a maximum. I think it's fine. It's pretty visible, so we don't really need a background. Yeah, I think it's pretty visible. We don't really need to do anything here. We can just move it above, and it will say game over. If you want to be sure it is in the center, you can go over here, hold Alt and click center, and then just move it up. Now we want to add a button over here that will say try again. Now let's make UI button. Try again button. Let's make it bigger, like 400, no, 200 by 100. I like slim buttons, so I'm gonna try 250 or even 300. Yeah, this looks okay to me. The color of a button is like it's not looking good. So let's try make it black. Well, it is because of the image. If you have different image, it will be better, but we don't have anything, so I mean, it's fine. It's okay. Let's go to text, make it white, auto size, change font, do center, and type something like try again, or better, restart, right? And you can simply attach this button to the text over here. Does it look good? Maybe to fit the style of these UI elements, this is actually not that bad for UI. I mean, it was assembled just like that. It doesn't look so bad. I like it. We can make it this much wide. So it's gonna serve as a, yeah, this is cool. I love it. Okay, this button will be functional just like that, even before you do any setup. But we do need to have setup on a button. So let's go to the UI class and make a function that will restart the game. We go to UI and make a public void restart level, in which we do int scene index equals to scene manager get active scene build index, and then we do scene manager load scene with a scene index. So this will get index we have on the current scene, and this will restart the scene. So it will be just a simple restart of the level. And we also want to have a function that would show game over UI. For that, we need to have private game object game over UI reference, and then we need a function public void enable game over UI. It will simply do game over UI, not game object, but game over UI, set active true. I don't remember if I told you this, but if you have just one line of code in the function, you can type lambda expression and that one line of code, and it will work. Okay, now that we have it, we can go to object to protect, and if it dies, we're supposed to show game over to the player. So let's override die function. Let's do game, UI instance, enable game over UI. So if object to protect getting killed, then it will enable game over UI. And maybe we can slow down the time in the game so it looks more disastrous. Yeah. So let's go to UI over here, and maybe let's just expand it and do time. The time scale equals to 0.5. So this will slow down the game by 50%. And then in the awake over here, we just need to do time scale equals to 1. Because if you don't do this, when you restart the scene, you will still have time scale as 0.5. That's why you need to reset it in the awake. So UI is acting as UI and a game manager at the same time. Perfect. Now let's go back to object to protect and do, oh, we have the function. Okay, sorry. Let's go to player and finish game as well if player dies. So override die, UI instance, enable game over UI. Now we can test it. Let's save this and let's go back. We need to assign game over UI, so we take this object and drag it here. Then we switch it off by default. We don't want to see it. And we start the game. I'm gonna let skeleton kill the object and see the result. Gonna run around, see the things, 1 attack, 2 attacks, and everything is slower, and we can see game over UI. And we can click restart, and it doesn't work because I forgot to assign the function, but it's okay. Let's go to game over UI, find the button, and over here you can add on click function. And this will be called every time you click the button. You drag the canvas, you find UI, restart level. Let's switch it off by default, and let's test it. One, two. Okay, and I can click restart, and level is restarted. Perfect. Now, the only thing left to do is to respawn more skeletons, so game becomes harder. Otherwise, it's pretty much cool enough, right? Yeah. Let's do it in the next chapter. I'm gonna save this, and let's go. Hey guys, time to respawn enemies. How are we gonna do that? So I have two options. We can respawn enemies off the screen, or we can respawn them on the screen somewhere here, and they're gonna drop like so. Both options are fine and both very easy to implement. We need, first thing we need is prefab folder. Prefab. And we do have many folders here, so maybe let's make folder for scripts. Take this, drag them here. We can close it for now. And on the prefab folder, we need to open it and drag enemy into prefab. Here is why. When you do that, you make a copy of the object. It's like a blueprint that you can use to make new enemies, like that. So it's the same enemy, but the different one. Basically a new enemy made by settings you made before. And what we need to do now is to use this prefab to create objects on the go. Quite easy to do. We just need a script. So we're going to make a script, enemy respawner. We did discuss cooldowns and timers before, right? So I'm not going to stop on that too much. I'll just implement the functionality. I bet you want to finish this one already. So let's do it quickly. Let's do serialize field, private float cooldown, and let's do private float timer. Then in the update, we do timer minus equals time dot delta time, and then if timer is less than 0, then timer equals to cooldown, and we create new enemy. We generate method like that. Then to create an enemy, we need serialize field, private game object, enemy prefab. And we do want to make enemies on a certain spot. So we're going to make an array of respawn points. We're going to do serialize field, private transform, array. This will be a collection of objects, of transforms, and we do respawn points. Then when we create a new enemy, we do int respawn point index, which is equals to random range between 0 and respawn point dot length. It's not working, but we can go ahead over here and do, well, let's just remove using system, and it should fix it. And then we do game object new enemy equals to instantiate enemy prefab at respawn point with respawn point index, and we need Quartonian identity over here as a rotation. What else can we do here? We do need to, wait a second, I forgot to type dot position, like that. Maybe we could make it cleaner. What do you say? Let's do vector 3 spawn point. So when you type transform dot position, it gives you vector 3. So you can get vector 3 directly. I cannot say 3. 3, 3. So you can get vector 3. Hell, I usually say it fine, but now. So you can make vector 3 variable and then make it equals to transform dot position. So what we're going to do is we're going to make respawn points with an index dot position, and then we use it over here to make it easier to read. Spawn point. We only want to adjust rotation of the skeleton, because if you make skeleton on the right side of the player, it should move to the left. But we cannot really just rotate the skeleton from here, because we also need to adjust facing direction and so on and so on. So this is what I want to do. I want to go to entity. It's not available. It's okay. We can close other tabs and find the entity over here. And I want to make public function, flip function public over here. I'll make it as public. Now I can use it on enemy respawner. And I'm going to save this and go to enemy respawner. I will make a reference to the player. Let's just do private transform player. Then in the awake, we can do player equals to find first object by type of a player dot transform. And then we're going to check if enemy was created on the left or right side of the player. So we're going to do bool created on the right. And this boolean will be true if new enemy transform position dot x is bigger than player transform position dot x. And if so, if created on the right, we're going to take new enemy, get component of the enemy, and do flip function. Got what we're doing here, right? So we're creating an enemy, and then we check if this enemy is on the right side of the player. If so, we get in component of the enemy and call flip function. By the way, you don't have to create this local boolean. You can just type this in the if statement over here. but I find it easier to understand when you have an extra parameter. Okay, basically respawner is ready. Let's save this and let's go back. Wait, no, I actually want to do something. I want to make it harder with the time. So maybe every time we create a new skeleton, we can slightly reduce cooldown, just by a little bit, but it will be enough to make game harder. You will have to balance it out yourself, but the logic should be something like this. Let's do private float, cooldown, decrease rate, and let's say we reduce cooldown by 0.5 every time we create a new skeleton. So we go here and do cooldown equals to, and we don't want to set it below certain value. I mean, we need to have a limit because otherwise you will have cooldown 0 and you'll just create 1000 of them in a second, right? So we do cooldown math F and we can choose maximum value out of 2 available values. So we do math F maximum and we either use, let's make serialize field, private float, cooldown cap. So let's say cooldown cannot be lower than 0.7 F. By default, it would be 2 seconds. And then over here, we choose between cooldown cap and cooldown that we have right now minus cooldown decreasement rate. So what did we do? We created a very small variable, and every time we create in a skeleton, we do cooldown minus cooldown decrease rate. So we reduce cooldown by 0.5 every time we make a new one. And we check at the same time if this value is less than cooldown cap. Because if it is, then cooldown cap will be used, because math f.max choosing the maximum value out of 2 available values. All right, this is good. Let's go back to Unity. Let's make enemy respawner. And it doesn't matter what position you have for it, but you need to have two. You need to have 2 respawn points or more, depends on how you want to have it. Let's make a circle so we can see it. Okay, gonna make it red, and I'm gonna do point. Let's make it like 0.5. I don't know, cannot really see it. Okay, let's use built-in gizmo. We can do it over here. And this one should be visible. Yeah, nice. And let's place 1 point over here, and then duplicate it and place another point over here. Then find enemy respawner, attach script, attach first point, second point. You have them here. And assign enemy prefab. In the asset, you have enemy. Now this one can be deleted. You have respawner, and if you go to play mode, you're gonna see how enemies are created all the time. 1 and 2. We're choosing randomly, so 2 of them were created on the left. You need to go ahead and defend the girl, and there are more and more skeletons. This is what makes it fun. Yay, love it. You can see more and more skeletons coming up, so this is cool. We can go ahead out of the level if we want to, like that. So we need to fix that. And also I can see I can kill skeletons even though they are quite far from me. So first limitation. Let's make empty object, level limits. We're gonna give it box collider 2D. Make it just long like that. Place it here, right? And we need a layer, level limit. Assign it over here, level limit, duplicate it, move it to the right like that. So, sorry, did not duplicate it. Duplicate it, move it to the left. Now we have 1 and 2. We can drag them into level like that. And we go to edit, project settings, physics 2D, find level limit, and disable collision between level limit and the enemy. So enemies can pass by, but player cannot. Alright, this is good. What else? Oh, the attack. So on Animator, let's check the attack range. Could be slightly to the left, maybe, like that. I will not reduce the radius, so you can kill enemies that are standing basically inside of you, but it should be slightly shorter. As for enemies, let me double check. Well, maybe let's do slightly less as well, like that, because range is very high for them. Okay, and yeah. So we did it. I did make a very long video for YouTube. You completed the course. How cool we are, huh? I hope it was an enjoyable tutorial. Took me a good amount of time to make, and I appreciate you sticking to the end up to this point. You should know that, of course, there could be more things done in this simple game. You could add lots of more mechanics and features, but I wanted to keep it like short. 6 hours, right? Yeah, so there is always something to improve, but just take it as a stepping stone and try to make something else, all right? If you want to check out my RPG course, lots of things to learn there, very cool one. And I want to say thanks to all my students and Patreons, and give special thanks to Gianni Maroni, I hope I said that right, and Bardent. Thanks to you guys, these videos are possible.